It looks like we are live. Hello, everybody, and welcome back to another Hangout. Today, or actually in the last few days, Mr. Thrive and Survive has uploaded 2 new videos. I actually haven't seen a single one of them, like just 2 or 3 seconds for audio testing purposes. And we are going to take a look at those. With me, I have Bo Holbo, Microblog, Neslick20, and the Rumpus.
Hello.
So hello, everybody.
Hey. Hey.
Okay, so you might be able to see that I'm actually in this Hangout twice. That is caused by the fact that I'm using a new audio system in which I'm running the actual video that we are going to play on my secondary machine on the side. So we're gonna just screen share that. There we go. And let's just check if the chat or the stream can actually see this. Oh, the lag is high today. 30 seconds maybe.
I can see the live stream, but can somebody in the live chat say whether you can see it or not?
So I'm watching. I can see
there
it.
We go.
It's working. Yes.
Okay, so there are 2 videos in question, and we're just gonna start with the older one, which is called "New Video of Moon and Stars Destroys Globe Flat Earth." So let's start right in with this.
Oh,
yeah, yippee!
I'm still confused, like by his intro. I keep thinking it's an ad.
Okay.
It is an ad for stupidity.
What we're gonna do is, since last time the actual debunking became kind of a clusterfuck, we're just gonna let it run point by point and try not to interrupt the actual video.
Yeah.
So let's just start.
The operant word being try.
Hello out there in Flat Earth land. This is Rich, Mr. Thrive and Survive, and it is August 24th, 2018. You are looking at a screenshot of a video, a absolutely marvelous video, which was presented on Sun and Moon Family United channel. And I will link to that below this particular video. If you haven't subscribed to Sun and Moon Family United, I would highly suggest you do. Not only do you get a lot of flat earth, but you get a lot of related and even unrelated subjects that, anyway, they appear unrelated, but they sort of correlate together. Big overall picture. The big overall picture is we're lied about everything. On that channel, there's a lot of people doing their own independent work, coming to conclusions that science should have and probably has actually come to long ago, but it's been suppressed from us. So let's take a look at one aspect of this video. Now, I'm probably going to come back to this video many times. There are a lot of great takeaways that you can get from this video. Now, I don't necessarily 100% conclusions that Dave Marsh, who is the creator of this video, came up with, but there is a lot of fantastic work that he has done and that I think others can build off of as well. Now, he is at one point calling this, as you see here, Moon Race, the motions of the moon from a flat earth perspective. And he opens up an entire can of brand new thing, Lunar Lemma presentation. That is a term he came up with. The Motions of the Moon by Dave Marsh. And let's go ahead and skip ahead here and take a look at something. Now, what he did in this video, he took his own independent observations, and he also went to timeanddate.com and also to this site, which I'm not sure exactly what the site is called, but it is a NASA-based site where it gives you the different lunar phases. And more importantly, for this part of the presentation he did in this video, it gives you the cycle and how far away the moon is from the Earth according to NASA's model. And what you will find out, and what I will show in a different video, is that Kepler's second law of planetary motions and different things like that is absolutely obliterated if the moon is a solid object like we've been presented, you know, that it's something that's rotating around the Earth. It is a planetary body, so to speak, a moon, and solid material, and not just a light up there. And either Kepler's second law of motion is obliterated along with gravity, by the way, or the moon is not, we've been told, it is not a orbiting body that is solid and is subject to gravity. That is for another video. What he came up with in this video for me was a couple of observations with actually the stars, star trails. That's particularly what I'm going to be talking about here, but also, if you will, lunar trails or the path of the moon. And both of those would be impossible if we live on a spinning ball. And that is the point of this video, to show that in a brief amount of time as possible. So let's jump right in.
Finally.
Alrighty then, we're going to look at what would happen if you're standing on a spinning ball on an axis like the Earth is on a fixed axis. And I got to bring this up. I'm sorry for you who are more intelligent and more up to date with this stuff, but
Hello.
the Earth does not wobble lightly on its axis according to science. None of us will ever experience a wobble because it takes hundreds of thousands of years to happen, or whatever they say. So believe it or not, people will comment and say that's the reason for what we're about to experience here. So the Earth, if you're standing on the Earth here, let's say at this intersection of these two lines, and you're looking up at a star over here. Oh, almost forgot. We have to tilt it because people will leave a comment. You didn't tilt it on its axis. That's the problem. All right, that's tilted at what? 23.4 degrees.
Okay, I think we should stop here because there's actually already some stuff that needs an immediate correction.
Yeah, and I think I can already guess it, because it doesn't take into account the relative angle with respect to the plane of the moon's orbit.
Yes, that's one thing, but I think, well, we don't know if he's actually going to this. What I just noticed is that the way that he presents the tilt, if you set the tilt to 23.4 degrees, then the other value should be 0 and not 90.
Yeah.
What is that 90? I just didn't understand.
That's what he started out at.
When a tilt of a planet is 90 degrees, that means that, well, when it's 0 degrees, that means that the axis of rotation is actually perpendicular to its orbit.
Yeah.
And when you give it at 90 degrees, then the
It's rolling.
rotation is exactly. It's
like Uranus.
Yeah, I mean, exactly like Uranus. Yeah, I mean, I presume in his world, he's just saying that 90 degrees to him means 90 degrees perpendicular to the ecliptic, and then this 23.4 is obviously what he thinks is the difference. That's really a difference. That's a delta rather than being an absolute, I think he would claim.
Yeah, but I mean, he's not like, he's just using different reference point. He's still like, the model he's presenting is still technically correct. Like, it still has the appropriate tilt. So.
Yeah, I mean, I think he's thinking that's a delta, but yeah, he's not absolute. I mean, yeah, it's sloppy, obviously, but yeah, I think if you were to ask him, he knows that 90. Although he's calling it 90 degrees, we're calling it 0. He's not claiming it's pointing at the sun. So although he's put the numbers there, I think he knows what the right angles are.
Not that stupid.
Yeah.
Careful.
And the second thing that he was talking about was the apparent, quote, wobble of the axis of the Earth. Is he talking about the grand cycle, like the precession movement?
Yeah, I think he is. No, not the precession. I think the angle of the Earth, because it also goes back and forward a few degrees.
So I mean, he's actually.
But that is the precession.
Change of the tilt.
Hold on, it doesn't.
I don't know. Precession is the.
It doesn't go back and
difficult
forward.
to explain. It's difficult to explain without visuals, so I will look up some visuals to explain it.
Oh yeah. That's the question. Is he talking about the precession, or is he actually talking about the change of tilt? Because precession implies that there's no change of tilt, right? When you have a precession movement, the tilt stays identical.
Well, it changes. Well, the tilt changes. If you think of the tilt pointing at a star, then it is changing. But precession does cause the tilt to change. So for instance,
because the tilt is relative to the Earth's orbit.
Yeah, but it points the other.
I think he's talking about obliquity instead of precession, because that is different.
I think you might be right.
Yeah.
But the precession will mean that the Earth actually points at the axis of the Earth actually points at a different star through precession.
Yes,
Yes.
exactly.
Right.
Yeah.
So
I
you
think
saying it wasn't. You were
It takes
saying it.
about 23 or 26,000 years for
Yeah, and you were saying it didn't do that. So I didn't. I didn't.
No.
Mm.
What I'm saying is that during an entire period of precession, the axial tilt will actually be identical.
Yeah.
Well, okay, the angle will be a point at different things.
Yes, it will point at different things, but the value of 23.4 degrees will stay identical.
Yeah.
yes.
But
Although
of course, both can change at the same time during the precession.
yes, I mean, if you the way to draw it, if you could draw a little circle above that planet, then you can think of the axis as being on the edge, pointing at the edge of a circle. If you draw a little ellipse above this,
I have the picture right here.
Let me show you the screen.
Cliff Jumper.
yeah, that's it. Yeah, the precession one. Yeah, you got it there.
There we go. Exactly.
Yes, and the obliquity. This is this little wobble that's caused
Yes,
by.
I mean that's the question. Is he talking about the obliquity or is he talking about the precession? Because I have the feeling that he's talking about the precession.
Yeah.
He might be
I don't
referring
know.
to both.
Or maybe both. I don't know. Maybe he thinks they are both the same thing. But still, I think we should just go ahead and watch the movie further.
Maybe, yes.
Yeah.
So share this and let's continue.
Means we're not 90 degrees upward. We have to subtract 23.4. What does that leave us with?
Oh man!
Stop! I promised to do a few minutes, but this is just too ridiculous.
Oh my god.
First of all, from upright, which angle is upright? It's 0, not 90.
Yes. So
No.
okay, was that stupid?
Yeah.
Well, stupid in one regard anyway.
Oh god.
God, I mean, really.
And actually, I'm not sure if he's rounding it correctly. Isn't it 23.3 degrees?
Yeah.
Yeah.
Check.
Hello, Sly.
Slice? Hey, Sly. Oh, it actually is 23.4 right now.
Yeah.
Ich will auch spielen.
Willst du auch
Yay.
spielen?
No.
Welcome to the sandbox.
Vielleicht
Why are we entertaining the 666 when it only has to do with a quarter of a rotation?
Ask Mr. Thrive and Survive.
Shit. How many flat earthers have put this out, man? I mean, it's an arbitrary subtraction of a quarter of a circle.
Yeah.
But,
I mean, really.
but Satan, even though that's not the number of the beast,
Okay, so Satan only has to do with a quarter of a circle?
I don't fucking know.
There's a deep message in here somewhere for us, obviously.
But except that's not the actual number of the beast. Like it's 661 or 616.
That's right. Yeah, it's not actually 666, is it?
Well, and plus, 667 is Satan's neighbor. Who cares?
Yeah, exactly. Yeah, we don't. I mean, that's why Geo stopped it, because to ridicule this. Yes.
Yeah, I mean, that's just.
Have you seen the episode where Cartman starts with the presentation and trying to subtract and add numbers and then blames Kyle for 9/11?
Yeah.
Yeah, this is exactly what I think about when I see things like this.
Ah, jeez.
You can see where these guys are coming from. They're just basic. Most of them, about half of them, are just religious zealots who just hate science. They want to go back to ignorance and a thing we used to believe in. Well, some people believed 2,000 years ago. That's their agenda. And all this science and facts and reality is just threatening all of this bollocks. And that's what they object to so much. Oh,
jeez.
Oh,
yeah.
Okay, let's actually try to let this run for 1 more minute.
Is that a coincidence? I'm going to start pointing out these coincidences because they're not coincidences. Now let's start to take a look at this from reality's point of view. If you're on a spinning ball,
reality,
if the person is standing here at this coordinate looking up at a star, we're going to show the same person down here. Of course, the Earth is rotating towards the east according to the official model. And this is what the observer should observe overhead with the star trail. As the Earth spins, it should be a line. Now, that's around the supposed curve, whatever the stars,
Stop.
either because of the Earth's spin or
Yeah, I actually have to stop because I'm utterly confused.
Yes, I'm utterly confused. What perspective is that from?
No, I know what he's talking about, but he's got his line at the wrong angle. He's talking about the transition of a star across the sky and all this. Now he's pointing it basically not even close to. He should be pointing it, if anything, he should be doing his line in the direction of that arrow instead of the dashed line kind of coming canted at it for some
Well,
reason.
the opposite, surely. The arrow is the rotation of the Earth, isn't it? So it should be the opposite to that.
Well, I mean that would be if you were looking at if you were at the equator and you were looking directly up at the stars, then you should see the line that he has there, the dashed line there, but that line would be equal to the equator. Right now he's got it canted. If it looks horizontal on the screen,
Yeah, I don't know
but it's not perpendicular to.
Yeah, sorry, I can't say where the hell is that supposed to be with respect to? And it's also going in the wrong direction. The Earth is rotating that way round, and therefore you would see it going the other way.
Well, depending on which hemisphere you're in, but yeah.
Well, no, if you're on the equator and it's rotating as that arrow's indicating, I think if that arrow was an angle, then the star would be going right to left, not left to right.
Hold on. Let me get this in my head here. Yeah, it would be going right to left, not left to right.
Yes.
Right.
So, but he's just drawn a star, and I have no idea is he trying to reflect the star? Is this star what we're supposed to be looking at? How we would? Should there be a little box around it saying this is what you view? I mean,
well, to defend Mr. Thrive and to defend Rich here. One thing that Rich absolutely sucks at and therefore draws his conclusions from is making diagrams.
Right.
He absolutely sucks at it.
Are you sure that's a defense lie?
Well, I'm just saying that's
Fly,
where he gets his shit from.
Fly, please never defend me.
No. What I'm saying is he draws these diagrams and this is how he draws his conclusions.
In other words, he's handicapped by his inability to draw diagrams, and therefore any intellect he's got is having to deal with his handicapped drawing ability. Is that what
precisely? He even had at one point a 3D program, and I don't know which one it was, but he had this kind of gold and black Earth and all this, and he couldn't understand how somebody in, let's say, Greenland could get 12 hours of sunlight on the equinox the same as someone in Ecuador. Because he said that the top would be rotating slower, therefore it wouldn't work the same way.
Oh God!
And he did that just by drawing a screwed up ass diagram, and therefore drawing his conclusion from that.
Even Riley or Nathan wouldn't get that wrong.
I'm not so sure about this.
Don't give him too much credit.
Yeah, no.
So do we think, boys and girls, whether this star that's got a line, is that supposed to be in a sort of separate box of what we're looking at as an observer?
You mean the one on the bottom?
Yeah, the one on the bottom is
yes, it's definitely unrelated to the planet that's drawn on top of it.
It's not unrelated, but it's not
on the same reference frame, right?
No, it's
a different diagram.
That's what someone on the ground would see.
Right, which would be wrong, of course, because it's going in the wrong direction. But there we go.
And at the wrong angle.
Yes,
and the wrong angle, wrong direction, and it would also kind of circle, wouldn't it? Put it straight.
It's not a good start, is it?
Well, it's not really much of a start considering that we're 5 minutes into a 12-minute video.
Yeah, but 3 minutes of the video were like advertisements or intro, and then advertisements for another channel.
Yeah, more garbage.
Yeah, it's pretty much at the start. That's fair.
More garbage.
Let's continue.
Because of perspective, appear to rise and set either way. At the same time, this is a representation of the person on the right, seeing the star rise as it spins, and we end up with a semicircle in this case. And of course, if the star is higher up in the sky, we would get an entire circle with a 24-hour spin, that is correct. I think we all agree on this. If you go to anything like a planetarium or if online a stellarium viewpoint, even with the different views they have, they pretty much all agree with this. Now, if you put multiple stars on, what will we get? Well, you would end up with stars that have, like this, parallel circular paths. And of course, as you got towards Polaris, you would have smaller and smaller arcs, correct?
Oh God, I know where he's going. I know where he's going.
Just a quick remark. What he is illustrating there at the bottom is something that you will see at the equator. This pattern, what he is now showing. Not the picture above, but the illustration below.
The illustration would be basically anybody pointing the camera at Polaris in the northern hemisphere.
And I mean, not the picture above. I mean the illustration, the dotted blue lines.
No, that's what I mean. Except for the fact that I think he's got his dot there in the wrong place, of course.
I'll go further then.
So the way he's drawn it, it looks like that the stick figure on the bottom left sits pretty much directly on the equator.
Yeah, exactly.
Yes, so this is not identical to the drawing he's made on the top left, where the observers are standing like at maybe 50 degrees north or something. So therefore, on the position of this observer, the pole star would actually be 50 degrees above the horizon.
Mm-hmm.
I'm honestly not sure about, like, he's really bad at explaining, he's really bad at drawing diagrams.
Well, what is the boss of the catch on the left now doing? So we now got two observers. What's the one on the left observing?
I don't know.
I have no idea.
I was thinking you all understood this, and I was thinking, what the hell?
Well, hold on. I do have one question, though. The picture that he has up, the actual photograph, that's pointing south, isn't it?
That's the oh look, that's
Polaris. Star. Yes, you're right. I think it is.
That's the same picture that Eric Dubé.
Antonio.
Antonio used. Yes, the same picture that Antonio used to say, "Oh look, that's Polaris."
Well, no, there was an observatory in that picture. I debunked that personally.
No?
But,
it's pretty close to it. You can see that it's the south, or it's likely the south celestial pole.
Actually, I'm gonna look up images while we're doing this. So
I mean, this to me looks like it's a constructed picture. The foreground to me looks as if it's just been pasted on the background.
That's entirely possible as well.
Maybe
the one in Sydney that we've seen a couple of times is actually a superimposing of one on the other.
Right.
No, I think let's play the video further, so just to see where he's going with this.
Yep, more garbage.
More garbage.
Correct. You would never have one coming in towards another. That would indicate that we're actually not on a ball. We're actually diverging away from one another.
Can we
so
stop
this
for a moment?
actually experience.
Okay, Micro.
I looked up star trails on Google. It's literally the first picture you get.
Really?
Oh, God.
So which celestial pole is it?
Yeah, South Pole.
There we go.
Thanks, Thrive and Survive. You just proved the globe.
Yep. That's literally the first fucking photo.
It's actually the picture in Wikipedia. No bullshit. Look at my screen. It's actually the one in Wikipedia.
Yes.
All he did was crop it.
Oh God.
It's the one in Wikipedia. This big pretty job right here.
He's a hardcore researcher, that's for sure.
Any
that's the level of research from the flat earthers.
Slide, any information about where it was taken?
Not directly, no. That is just the picture, though. Hey, there's one of the ones.
There's a source of it. It's from Chile's Atacama Desert. Yes.
Yeah.
Okay, Chile.
Yep.
So
thanks, Rich.
Thanks.
Okay, let's continue.
On the Earth. Okay, now we're into the heart of it. This is back to the video that Dave Marsh did on Sun and Moon Family United. I encourage you to go see this in motion, but it starts with the star trails in their original position and then taking off. Here's the moon on the Tropic of Capricorn. He also shows it on the Tropic of Cancer. What I want you to see here is that the moon is doing a curve. You can see the arc, hopefully. And these stars down here are doing the same sort of arc, same thing that we were talking about. However, when you get up to the middle here, these are going in a straight line. And then these are diverging off on the other side, you can hopefully see that there's an arc going to the other side. How is that possible if you're in a fixed?
Okay. Before he comes to his well, actually, let's make him make his point first. But I'm pretty sure that I know what he's talking about here. So
position on the Earth looking up. How can you see some stars rotating around one center, diverging off to the right in this case, diverging off to the left, and in the middle they're straight ahead? This is impossible. They should all be going the same way from your perspective. Let's take a look.
Okay, going to Celestia.
Also, the line that he draw here, he drew here, they don't match the star.
I think they're just supposed to be representative.
Yeah.
But I love that he says they're not going the same way.
Not Celestia, Stellarium.
They are going the same way.
Yeah, because
they're going in the same direction.
They are slightly curved. I mean, as you say, someone's saying is exaggerated, but one is curved. There are concave and convex curves, I think, here, just.
Yeah.
Okay, so let's place them somewhere in the Atacama Desert. So
that's right, but if you're on the pole, you can do this. If you're on the equator, of course, you can do this.
Yeah? Is that fair?
Is that where he said this was? So I thought this video he said this guy had taken, he didn't say where, I missed where it's from.
Did he say where it was taken from?
No.
Because you can only get this effect, obviously, if you're at the equator.
Didn't he say?
Not exactly,
or near the equator?
Near the equator.
Yeah.
Okay, so let's just try the Atacama Desert, approximately there. So.
Yeah, but that was, hold on, Gio. The picture from that Wikipedia was from the Atacama Desert. That's got nothing to do with this video, surely.
Okay, so
we're just choosing some place to illustrate that this.
I mean, we can run the relevant part of the video again and find out whether he actually.
He mentioned who it was, didn't he? He mentioned where the video.
Let's try this. I just run the audio in the background again.
That Dave Marsh did on Sun and Moon Family United. I encourage you to go see this in motion, but it starts with the star trails in their original position and then taking off. Here's the moon on the Tropic of Capricorn. He also shows it on the Tropic of Cancer. What I want you to see here is that the moon is doing a curve. You can see the arc, hopefully. And these stars down here are doing the same sort of arc, same thing that we were talking about. However, when you get up to the middle here, these are going in a straight line, and then these are diverging off on the other side. You can hopefully see that there's an arc going to the other side. How is that possible if you're in a fixed position on the Earth looking up? How can you see some stars rotating around one center, diverging off to the right in this case, diverging off to the left, and in the middle, they're straight ahead?
Model is on the way.
Impossible. They should all be going the same way from your.
Okay, stop. I think that's enough. So when we actually go to Stellarium, and I actually activated the equatorial coordinate grid.
Yeah.
So the star trail lines correspond to the lines that circle around the celestial poles.
I think you can call them celestial longitude, latitude lines.
Gio, are you trying to share this?
Yeah, you have to click on my.
Oh, I see. Right in here. Okay. Right.
I should be sharing it to the live stream, though.
Okay, that's what I wondered. I couldn't.
You can already see that the celestial latitude lines
there we go.
Still don't go all in a straight line.
That's better. So yeah, first of all that. So there we go. That's the relevant part of the picture.
Yeah.
Do you already see it?
Open your field of view. You can see it even better.
Oh, there we go. So actually,
because I'll bet you he's going to bring up one of those wide angle shots.
Yeah, it's a wide angle lens effect. Obviously.
So let's see. Screenshot that.
Yeah, someone in live did already pointed out there are two centers of rotation, and that's why not all of them go in a straight line. So he's basically building a strawman fallacy.
So let's see. That one doesn't appear to be straight, and what doesn't appear to be straight, but in the opposite direction. So does that already count as a debunk?
Yeah.
Yes.
I think
Pretty
so.
much.
Okay, there we go. Don't need that.
Yeah, so to give a more quick explanation, the stars are basically on the celestial sphere, and they rotate around with it.
Yeah, the idea, like, in his mind, they're apparently going different directions, even though they're just going the same direction around a sphere. Like,
yeah,
that's it. This is entirely what you would expect.
Because you've actually got both poles in this picture, haven't you? You've got that's the south pole there on the right. And
Yeah,
the north pole is
obviously, Rumpus, you can only see one celestial pole.
Gio, can
This
you
is standing
turn
directly
off?
on the equator,
okay,
in which case you can actually see both directly
the
on the
other pole is
horizon.
not. No, well, hold on, Gio. The thing on the left where it says north, that just around there, just a little bit further down, you can't quite see it, but that's where the other pole is.
Yeah.
Yeah, but it's under the horizon.
Yeah.
Yes, just yeah.
But Gio, can you do?
So you're looking at more than 180. You're looking at over 180, nearly 180 degrees here.
Gio, can you turn off the atmosphere to see the stars and play it a bit for a while, so you can see how the stars move along the celestial sphere or the celestial grid.
But can you see it says north there and south at the other end? That is 180
there we go.
degrees.
Yeah.
So I've actually accelerated the speed of time.
Yeah.
So it's moving fast.
So this is super fisheye look. So the question is, does the video? Well, you're going to get some.
I love this. This is cool.
Hey, did you know? Quick little fact. Did you know that Stellarium is what Rob Skiba used to do his sun and moon calendar map from the South Pole?
And what does this sun and calendar moon map show?
That one that it's the AE map with the sun and the moon going around it.
I haven't seen his map.
What?
Sorry, I've seen the AE map.
That's been out for like ages. Where he has the sun and the moon chasing each other around the top of it, and what do you call it? He actually did that in Stellarium.
I have to go and look at that, right?
Oh, look, they matched the picture.
Yeah.
Okay, so let's go back to the video.
So quick rebuttal. No, they don't go all in a straight line, and we shouldn't expect them to, based on the flat Earth model.
Well, not only should we expect them not to be on a straight line, but we actually expect that the direction is.
A straight line only accounts for when you look. Yeah.
When you look directly at something that is on the equator.
Yes, exactly. And when you turn on in the direction of any of the celestial poles, then the stars would go in a more circular path.
Exactly.
Yeah.
They will make a curve.
And this is exactly what we would expect if the Earth was a sphere and rotating, and the stars were very, very far away. Now.
Okay, let's continue.
I'm just laughing at the chat.
I saw
the side chat.
Electromagnetism.
Yeah, that's what I was laughing at.
That's close. That's very close to electrolysis. Okay, let's try if we get one more minute out of this.
More garbage.
Let's take a look at it from the Tropic of Cancer, farther north.
Show me the Tropic of Cancer.
Now we have the Tropic of Cancer. Look at the moon now. It's curving up to the left.
Stop. So actually, I'm just going in Stellarium and going to some location that's in the Tropic of Cancer.
Yeah.
So that's exactly 33 degrees north, isn't it?
Right. It's not even to South Florida, so he's not at the Tropic of Cancer.
So let's see, 33 degrees. Just click something randomly until I hit it approximately.
Very close. The south of Florida is very close to the.
Okay, so I'm somewhere in the southern east United States, Georgia maybe.
What?
Oh, the south of Florida is very close to the Tropic of Cancer.
It's close to it, but it's not there.
It's further south, actually.
Yeah.
Gio, can you please give the link in the group chat of this video so I can?
Yeah.
I think I noticed something, but I want to make sure.
Here, look. Tropic of Cancer, Tropic of Capricorn. Okay. So unless that picture was taken in Mexico, who cares about what he thinks it is? You know what I'm saying?
Yeah.
The Tropic of Cancer does not even reach CONUS, the continental United States.
That's right. Yes, it doesn't quite make it. No.
No. The equator goes through here and all this. You know, it basically it divides in the Caribbean, but that's the Caribbean, but that's it, and Mexico. So them saying that they were taking pictures, unless they were in Africa, or India, or southern China, or near Hawaii, but not even on Hawaii.
Yeah, he said that he saw the Tropic of Cancer. I didn't quite understand what he meant by that.
Well, you see, that's what he said like 3 times now. Tropic of Cancer and Tropic of Capricorn. How do you know what you're photographing?
Yeah.
If, I mean, if you're not there.
Yes, I didn't understand the statement at all. There's a Tropic of Cancer. Well, sorry, yeah.
Yeah, because I mean that's just a crock of shit anyway. So even claiming what he is, I mean, basically by acknowledging that the Tropic of Cancer and the Tropic of Capricorn would be actual positions relative to the celestial sphere, then he's basically just doing himself nothing.
Yeah, I didn't understand. Yeah, I didn't understand the comment at all.
Okay, so yeah, I was corrected actually in the side chat that I had to go for the south. I was at 33 degrees instead of 23.
Yeah, you were up there, and as soon as you said Georgia, I was like,
yeah. I was thinking that there must have been something wrong with this. Okay, so let's continue.
Gio, wait, can you? I both sent it to you on Discord, and I can see that Bo has put it in the side chat. SciFDK sent a picture to us that he wants us to show, and it's actually relevant.
Okay. That one that I'm screen sharing right now?
Yes, zoom out. There we go.
Super wide. I've seen that picture.
That's more than 180 degrees by definition.
Mm-hmm.
One celestial pole being here, the other one being approximately there, maybe?
Beautiful picture, by the way.
Yep.
Thanks, Saif.
But that has to be a composite, doesn't it?
Well, it doesn't matter if it's a composite or not.
Oh, yeah, it is a composite, but yeah.
Because it looks like there's approximately maybe 10 hours or so of a rotation of the stars seen. I'll zoom into this. It's a little bit pixely, unfortunately.
Oh, you can get some originals of that. That's
on the other side. That's somewhere between 6 and 8 hours, I'd say. So
I'd put it at about 6, maybe 7. Yeah.
Yeah.
What the fuck is Tom talking about? Poland used to be communist.
I mean,
well, he's a moron. So
it's Tom, man.
Poland used to be communist.
It did. Sorry.
I think he's making a Poland or Pole joke there.
I honestly don't know.
If the Poland win a prize. No, wait. Okay, more garbage.
Whereas before it was curving up and to the right. See the stars up here? They're curving to the left. And it's difficult here because you'll have to go and see the video. This is about 32 minutes into his video. We'll actually see these star trails progressing across the screen. I'll show it a little bit here.
Which is what you would expect if the Earth is round.
But you can see the star trails start to straighten up down here, and then they start curving off to the right. This is not possible if you're on a ball, and that is what's causing these star trails.
Really?
It has to be
exactly what we would expect.
Rotating with 2 different centers of location.
Stop.
2 different what?
Let's actually continue. Did you just say 2 different centers of rotation?
Yes. Repeat a bit.
Yeah.
Oh, and that is what's causing these star trails. It has to be caused by them rotating with 2 different centers of location rotation.
What?
Yeah. Yes, he said it.
At this.
Wait,
so he understands that there are 2 different centers of rotation.
Oh, right.
But it can't be the Earth. It has to be the star. That literally doesn't matter.
It makes no sense.
It's irrelevant. Like relativity is a thing.
One thing to notice is he wasn't using a fisheye, or he wasn't using a wide-angle lens there, from what I could see.
Yeah.
Doesn't look like it, no.
So
But still, you would still expect to see without a wide-angle lens this pattern of stars.
Depends. I mean, if you still have 10 degrees or so of field of view, that's more than enough to actually see this effect.
Yeah, exactly.
So can you do stellarium with just 10 degrees field of view just to demonstrate that?
Sure,
Make it
wait a
better.
second.
That would make a more
Stop.
effective point.
So
I think one box is like 10 degrees. Oh it zooms in, and so yeah.
So wait, so 10, 5, 0. So this is approximately from here to here would be 10 degrees.
Yeah.
I think you can actually. I need to.
Oh, we just guessed at 10, but it's probably.
Yes.
I think it's probably more than that, actually.
Probably, yeah. But
yeah.
you can still kind of see
a normal camera is 50. Is it a 50 millimeter lens? Which gives you, is it 45 degrees either side, or 30 degrees, 60 degrees?
Well, the picture that's currently in this video is much more than 10 degrees. Obviously.
Yeah, it's much more.
Yeah.
50, 60, something like that.
Yeah, more like 60. Yeah. Yeah. So what's 60? Yes. Can you do 60?
Plus 30, minus 20. So that's approximately 60
That's
degrees.
more like it. Yeah.
And you can see the celestial lines going to the right on the right and
like concave and
vice versa.
convex. Yeah.
Yes.
Yeah.
Oh,
Yeah,
actually,
that
I'm
matches.
screen
Okay.
sharing this.
Yeah, that's much closer match now.
There we go.
Yeah, so that's a more that's a better comparison.
Okay. Can you again fast forward the time lapse
Sure.
with the stars? You can see the same effect.
That's too fast.
Oh, too fast.
There we go.
Yeah, you can see if you look on the right, the stars appear to bank to the right, and if you look at the middle, it will appear to do a straight line, and on the left, they go out to the left. Because there are two celestial poles.
I mean, he kind of seems to be understanding this. What's his problem then with it?
I mean, he doesn't know how this would work on a round Earth. He thinks that this. I have no idea. He just thinks that it can't work on a round Earth for some reason.
Because reasons.
Yeah, because reasons.
More garbage?
More garbage.
More garbage.
Oh God.
Yes.
This one right here, you have stars obviously around the center of location up here. As you get towards the center, some of them still towards the top flare off to the right, straight, and they flare off to the left here. You have a star trail that actually, as it goes more into the night, diverges from stars over here where they were earlier in the night. The distances would be further apart as you are looking at them. You can see obviously there's a center of rotation over here. Whereas all of these, granted, you would see them appear to rise and fall and go in a circle if they're above the Earth for the entire rotation if you were on the ball, but you would not have divergence of stars. They would all have to be in a straight line other than the curve that it appears to be from rising and setting. This is impossible to be produced with a person on a sphere which is spinning in a straight line on an axis.
Stop. I think we are now at the point where Sly, are you able to simulate this?
What do you think I've been building?
There we go. I'm already screen sharing you.
Okay, check this out. Now, I'm not going to show you where I hit the fake the globe button. Hold on a second here. Star one. What I'm about to do, let's see, boom, like that. Okay, what I've done here is I just basically made a star field. It's just nothing more than just little bitty objects all the way around the outside of a sphere. Let me look at it from the right here. Okay, and here's our camera approximately where Geo and I live. Okay,
yep, that looks like approximately 50 degrees north.
And it's looking basically looking due south, but up by about maybe 45, maybe 50 degrees. Okay. Now, then I took the star field, and all I did was I just made it so it circles around. That's all it does. Okay. Now don't mind this circle here, don't mind this circle here. I just wanted more stars, so I took the original star field and I rotated it a little bit. Those are not meant to be the celestial poles. Okay. So, and then when I look over here through the camera, and when I play it, let me go ahead and just kind of scroll through it.
Oh God.
This is what I'm seeing through the camera. Okay. Now, the reason why I looked in this direction is because I wanted to split upwards and split downwards. Now, what I'm about to do here now is I'm going to render I'm about to render all 360 degrees of this and then put it through a star trail generator and see what it does.
Nice.
So what I'm going to do is let me just go ahead and let this render. It'll probably take about a minute or two. So, oh wow, it's actually going to go quite fast.
You need a faster computer, Sly.
No, it's going pretty fast actually. But nevertheless, what I'm doing is I'm just simulating rotating on the Earth. Only this time, you know, I rotate everything around it instead of rotating the Earth, and you're going to see exactly what it is that we see. And I'm halfway through now.
What field of view have you got here, Sly?
I have it at about 80 degrees.
Right. Okay.
Which is a decent non-distorting
slightly wide angle.
Wide angle, yeah. Okay. Okay. What the hell? What the hell just happened? Something aired. Hold on a second here. No, they're all there. Just one of them didn't make it for some reason. Yeah. Okay. So that's one of the images. Okay. So now what I'm gonna do is I'm gonna go over to this other.
You just have to superimpose them on top of each other, don't you?
Yeah.
Well, if it's a starfield generator, you just have one, can't you?
Well, I have no. You don't want to do that. What do you call it? I have. There's a free download out there. It's a guy from Germany who came up with this, and it's basically nothing more than a star trail generator. And all you do is, let's see, open files. You go over and grab these files. It's in, no, not that one.
No, I can't.
New folder 2. And then grab all these files. Yeah, it was just the last one for some reason it wigged out on it. I don't know why. And then add them all in. Oh, wait. Yeah, open. Now what it did was that just added all those to there. And now build star trails. You can have 2 different options. I'll just go for the easy one. And it's building it's building a star trail out of it. Now, mind you, this is a full 24-hour one, only because I don't have a couple billion objects to do. So I wanted to make sure I got full and complete lines.
So, and as we can see, we get the same effect that MrThriveAndSurvive is claiming is impossible.
Yeah.
Is that just a perspective effect due to the fact it's mapped to a linear thing rather than being a spherical perspective?
That answer I couldn't give you. It might be a little bit exaggerated because of the fact that my star field that I'm filming is a little bit closer.
Yeah.
What do you call it? But you know, I can cancel.
Yes, I mean, I don't know if you're familiar with this, but if you just do the perspective calculations for emulating what a camera does, if you move something further to the off the center, it becomes bigger.
Wait, see here's the point though. Watch this. Now, okay, something blew up on my damn reader, so I'm gonna have to build a new one there. No, I don't want to send an error report. Well, I'm gonna have to rebuild that. But as you saw,
I think we'll accept it as a debunk, won't we?
Yeah. I could do a much higher detail one.
That's a good effort though. That's a good effort in the time though.
It basically Rich, you're wrong again. That's all there really is to say about that.
Yeah.
So anyway, continuing.
More garbage?
More garbage.
More garbage.
Let's drive it home even more. How about this one? From the
There's
equator.
one.
I don't know which one is north and south, but look at this. This looks actually like the Polaris shot.
Hold on, yeah.
Equator?
Yeah, I just saw that. It's not from the equator.
No,
it's like maybe 20 degrees north or south, something
Yeah,
like
yeah.
that. Maybe
I'd
more.
say about 30. Hey, Rich, if you want to know where a photo was taken from, draw a perpendicular line straight up to one that meets it also straight up directly above it. Yeah, he's probably at about 20, maybe 30 degrees.
Well, it's easy to determine, isn't it? Because
Yeah.
when you take a look at the line in the middle, that corresponds to a star over the equator. You can just look at the angle that it's hitting the horizon. If it were straight or perpendicular to the horizon, it would be at the equator.
Yeah,
Or if you had some noted landmarks, you can also just judge by the height of Polaris or
Yes.
Octanus, whichever one.
But this looks like actually more than 30 degrees, I think.
Yeah.
Closer to 40.
Very handy on how you can use the globe Earth model to look at where you are simply based on the stars.
Oh, by the way, Rich, if this was taken at the equator, then the southern celestial pole and the northern celestial pole will be in the exact same place on the horizon.
Yeah, exact same height above
Height.
the horizon.
Same altitude. Yeah.
Right.
Elevation above the horizon.
Elevate. There's a difference between the two. Sorry.
The angular elevation would be the same, and
Yeah.
clearly we've got one on the bottom left is clearly rather lower elevation than the one on the right.
Yeah.
So
And Sly, in relation to your animation before, I put something in the internal chat from Cypher K earlier.
I'm reading
Yeah.
that. Oh yeah, no, 17 and 15 millimeter lenses with almost zero distortion. The distortion comes down to the actual shape of the lens and what do you call it? And it also there was a whole article that I read on it that what actually, because you can get wide angle lenses that actually do very little, if almost no distortion. But that would be across the horizontal plane, not across the vertical plane as well. There was something weird about that, but you can actually get those.
And they're kind of pricey. As far as I know.
They cost a couple bucks.
Yeah.
Okay.
Bit more than my 16,000 kroner fast lens.
Yeah.
16,000 kroner. That's like 2,000 bucks.
Yeah, it was basically the same price than for my Canon 5D Mark II.
Nice.
If I bought everything, from new, and it was a it's not a fast lens. It's a 400 millimeter. I can't remember, 1.4 stop lens, I think. So yeah, that's a lens where you have to mount the lens, not the camera, to a tripod.
I think we should play the video
tell that to Riley.
Yeah. I think we should play the video until the end now.
Yeah.
It's just 2 minutes or something like that.
Well, except for if he says something really stupid that needs to be.
There's a very high probability of that, I think.
Mm.
Yeah.
It can't be more obvious that we are not the ones rotating. There is a bent axis.
Stop. I have to interrupt him.
Bent axis.
Exactly the opposite is obvious.
Two things. First of all, it doesn't matter whether the stars are rotating around us or we are rotating. The geometry will be the exact same thing.
Yeah.
And second of all, bent axis.
Something's bent.
That's the wide angle lens. He's got some. Well, it's not.
Okay, let's continue.
Of the stars rotating. I've been trying to get a hold of Dr. Zach. He said he sent me a contact form. I never received it. But there is a model that I have in mind that will explain this. It cannot be explained on a spinning ball. It just can't happen with you being on the outside of a ball spinning, which would cause nothing but straight lines other than rising and falling. Simply impossible. Now let's take a look at something even more interesting.
Slide.
That is such bullshit. I mean, what other? I'm sorry that there was a deeper explanation needed there, but that is such bullshit.
Yeah, as we've demonstrated. With a simple model you've just created, you've shown that with a 3D model of the Earth, rotating it, see what the observer sees, and we get this effect.
Yeah, what he thinks is impossible on a spherical Earth is something that we would expect of it.
Well, they don't understand perspective, do they? Amongst other things.
Oh, don't say the P word. Don't say the P word.
No. They don't understand. Period.
Yeah,
Yeah.
angular size, angular changes, absolute positions. Yes, I mean, just
Oh God,
yes.
it's difficult to watch and listen to this bullshit.
Yeah.
But anyway, continue on. Sorry.
God.
With the moon. Now we're going to look at moon trails. And whether the moon is north or south is going to show something very surprising as well. The moon also follows the exact same thing. Let's take a look at
Well, yeah, of course it follows the exact same thing.
But the moon also changes every single day by about 5. What do you call it? Along its there's a 5-degree difference between the moon's orbit and the perpendicular position to the Earth's axis, and so it actually changes every day, but not by much,
Yeah.
but enough to see.
I mean,
Got it.
I mean, it's given the fact that it circulates us every 30 odd days, it's got to fit that every day. It's got to do a 30th of that.
That's not the point, Rumpus. The point is that the orbit of the moon is actually not in the same plane as the orbit of the Earth and the tilt of the Earth.
That's right. It's
Yeah.
5
Like
degrees
talking
off.
about.
Yes, it's 5 degrees off. Yes.
That's why we don't have a solar eclipse every year or so. Yeah.
Yeah, but
Or
I mean,
every month.
But I thought the point that Sly was making is that the moon moves relative to the stars by a certain amount. It's going to move by a 30th of its every night. It's going to have changed its position by a 30th of a whole orbit.
Well, I don't know what the exact number is, but it's
27.
actually 27.322
Yeah.
days.
Yeah. So is that not? Is that you're not agreeing with me there, Alex?
Yeah, of course you can see that.
Right. So that's what. Surely that's the point that Sly was making. With
No, I don't think he was. What?
Well, it's Sly. So you can show it again.
Wait, you didn't know that, GIF?
No.
yes.
The sleeping warrior.
Sly, just a small critique on that GIF. You have to make it a little more flashy, if you know what I mean.
Oh man, it's CGI, man. Back
More
off.
like gelatin.
I gave it a little bit of wiggle. How's that, man?
Yeah, but it looks like it has a point of articulation, like in the middle of it, where
Well, because that's where the sword is sticking in it, man.
Maybe a little
They think
leakage
the
at the
sword is
end of that
pointing,
sort
all the way.
attachment.
We are getting into
Details.
yeah. I think we're going to get into a clusterfuck mode. So let's move.
Yeah, we will
the
get
video.
into a clusterfuck mood anyway.
Yeah.
More garbage.
More garbage.
Fine, I'll take it down.
these are moon trails. Can you see what's happening? These ones at the bottom, you see how they curve as if there's a center of rotation at the bottom here.
Right.
And as it goes up,
Really?
it starts to straighten out. And
As
then
if
as it
there's
gets to the other side, it curves the other way, as if it's going around something up here.
Oh my God.
This cannot be explained with us on an axis spinning on the outside of the ball witnessing what's going on. Not from NASA.
It's the exact opposite. It's exactly what we should expect. It's the same damn rebuttal again and again. Yes, this is exactly what we would expect if the Earth is round.
Just showed it. Sorry, Rich.
Yeah.
Sly's already debunked it on the Star ones, yeah.
Okay.
Right.
And Stellarium. I mean, that's the point. You can go and look in Stellarium, as Alex did, and show this is what's happening. Initially, I was thinking you could only happen in the equator, but yes, it's.
Well, the next step that Flat Earth is actually, I don't think I've somebody do this, but I bet that at some point they will start betting that Stellarium doesn't yield accurate results. I mean,
I'll have to think about it. I had to think about it quite hard to think how Stellarium.
The closest thing that I've seen was I think Debbie that said that she didn't have the time or the ability to look at the stars for reasons, I guess.
I am very, very confident that she doesn't have the ability to interpret something that is fairly complex.
I just
or
wonder
do more than one thing at a time.
Yeah.
I just wonder if Rich is actually going to address in here the fact that across a flat Earth, star trails around Polaris, or if you want to say it would happen around Octanus as well, why star trails are not oval.
Yeah,
Yes.
exactly.
Yes. And of course, the fact you've got two poles, of course, we should be mentioning this, of course, the fact you can see two poles' centers of rotation would be impossible on a flat Earth when the stars are supposed to rotate on an axis that comes out of the North Pole upwards. And
They're supposed-
Purpose,
I have to
details.
do something. Somebody in the side chat, SciFDK, said that he used the old astronomy program that I once showed on DOSBox to do the same thing that I just did in Stellarium. And since I'm a bit of a nerd, I actually am going to do this right now. So,
What you gonna do?
DOSBox. I'm going to just use a program that has the same functionality as Stellarium. It's just 30 years or so older. So
He's a bit of a retro computer nerd, isn't he? So it's,
oh, how was it called? Completely
Been
forgot.
there, done that.
It should be Sky Globe.
yeah, so the point, just like make that point again, in case it's not been absorbed, the mere fact that you can see two centers of rotation is impossible on a flat Earth. It's only possible on a globe. So that one picture that they had of the two centers of rotation, or nearly, we couldn't quite see the other end, is impossible on a flat Earth and only possible on a sphere.
Yeah.
Sharing my screen here?
Yep.
Okay, so as you can see, the yellow lines represent... Yeah, the yellow lines...
Can you make the screen bigger of this page?
Wait a second, I think. There we go.
There you go, yeah.
That's the best I can do with this. Okay, so
we can see the yellow dotted lines, the celestial
You're not-
sphere. Yeah, the
Exactly.
celestial sphere,
Presenting, Gil. You're not presenting.
I should be presenting.
Yeah, well.
Oh, wait a second.
You're selected on somebody else, dude.
There we go. Okay, that's much better. What the heck? How can I?
Yeah, there you go.
Arrow.
How can I exit this?
Control C.
No faking the globe for
There we
you.
go.
There you go.
Okay, so
There you go.
there we go. That's it.
Yeah. That is the
Once less
map.
pole in this direction, once
Yeah.
less than pole in the other direction.
That is the map of the sky, and during any time of the day you can only see half of it because, of course, the horizon.
What field of view is that you've got there, Alex?
That's much. Let's see, altitude. Actually, I think I
the
have to
visual
go
field of view.
to a location on the equator to actually see this. So location.
I think it's about 30 degrees north or south. I don't know.
Well, the field of view is what I'm interested in, not the location of the observer. The field of view of the
that's
image.
pretty much directly on the equator. There we go.
That's the equator. Yes.
So-
And now you can see the celestial equator going in a
that's
straight
about
line.
approximately 60 degrees.
Right.
7 altitude. No, wait, stop. East, northeast.
Yeah, and so that shape, that characteristic shape you've got there, can only be possible if
Oh, it's
the
more. It's 100 degrees or more. Let me zoom in a little bit. If I knew
if
how-
the universe is rotating around us like along the axis of the axis of the Earth, or the Earth is rotating along its axis, about its axis.
45, 30. So that's approximately 75 degrees.
Right, which is a sort of yes, that's a sort of typical 50mm lens type thing. Yeah.
It's like, you know, what would be a cool experiment to do in home to get a camera and make it rotate on a single axis and see if you can get the same effect as shown in the computer program.
Oh, that shouldn't be that hard to do, actually. But I'm going to. I just recovered my stuff here, so I'm having a little bit of fun now.
The reason that I'm using this program every now and then is that Riley claimed that a few decades ago we weren't able to predict solar eclipses.
Oh my god!
And I actually showed that this MS-DOS program from 1989 is this version, maybe a little bit younger, maybe, I don't know, actually predicted the grand solar eclipse of 2017 in the United States fairly accurately.
Well, let's not forget Halley predicted the transition of the Venus.
What?
Transition of Venus across the sun.
Yes, and I think Halley also predicted the first solar eclipse using only mathematics, didn't he?
Hold on for a moment. Did Tom just say that the ice wall is 200 miles high? Oh, was it just a joke?
That sounds like a
High or
measurement.
tall?
That sounds like a tom-tom.
Yeah. I would love to know who did that measurement, though.
Yeah. We have pictures of this, of course.
Yeah.
Okay, more garbage. Let's end this first video
yeah.
so we can continue with the second one, which will be probably the worst as far as I know.
Oh God, no.
So, let's see.
NASA's model with the moon going around us? No. In fact, we're going to look at what's called the lunar analemma. Very interesting.
What?
So that's the end of this video.
He means analemma, doesn't he?
Analemma?
We can't now. We are so flabbergasted by it. We can't pronounce it anymore.
The lunar enema.
That sounds painful, Sly.
It does.
Okay, let's finish this.
I'd be curious to see how somebody can say this is possible. It's just
Really?
not.
Really?
Take care, guys. Bye.
Oh, what was it?
Stop! In the previous video, I taped the camera to the outside of the globe and recorded distant lights. There was no divergence from distant lights above and below the camera center. A globe can't produce the star trails we see. Bullshit, we've just proven that.
Yeah, Sly modeled it. You had a Solarium showing it. There we go. And it only works, it's only possible for the images you saw to work on a spherical Earth. You could not get that on a flat Earth. Well done, Thrive and Survive, for proving the globe, as you always do.
So there's still 7 seconds left of this video. For obvious reasons, I need to keep those right.
So here, look, check this out, Gio.
Okay, there we go.
Oh. Have you done your model, Sly?
Yeah, what I did was I remodeled it again. Because like I said, the shit crashed. I think it was just because of lack of space. But basically what I did was
Thrive and Survive August 20.
Oh,
Oh.
sorry.
Oh my god, is he gonna do the 90 thing? Oh Jesus. The anyway, this here we are again around 51 degrees, looking straight out from the axis of the Earth. Now instead of putting stars up, I just put, you know, bands of what the stars would be doing. And if I look at through the camera, and hold on a second here, if I increase the field of view, look what happens. I mean,
who would have thunk it?
Yeah. So, and if I turn my camera right now, I am rotating towards the South Pole. Or turn the camera, rotate it towards the North Pole. Or let me go ahead and see if I can simulate that one by getting a wide enough field of view. Let's see here. Wow, that's wonky.
Almost.
Yeah, it's just weird to get the rotation correctly.
And the field of view you're using is?
Right there is 137.
Right.
So basically, all you need is a wide angle lens and you can get that shot you had a minute ago. So, what was your point again, Rich? Oh, that's right. You don't understand things. So, anyway, continuing.
New garbage. Okay, so the new video is called Globe Fraud Right in Your Face. See yourself on Google Earth. I actually haven't watched that one as well. Apart from testing reasons, I had it running for a few seconds.
Wait a minute. Why is he doing 60 degrees?
The fuck do I know?
Isn't that supposed to be the whole 90 degrees by 90 degrees by 90 degrees thing?
No, he's just trying. He's going
Probably.
to talk about the sum of the triangle coming to 180. And he's just picked a triangle to test it against.
Okay.
Because I watched a couple of minutes of this one. I must admit, I'm a little bit confused by what Google Earth is doing, but I know it's my problem, not Google Earth.
I'm going to say I'm a little bit confused at what's trying to be shown here, because I know the triangle test on a sphere.
Yeah, that's what he's trying to. He's trying to say that on a sphere that the triangles do not sum to. Sorry, they do sum. I think he's going to say they do sum. Well, actually, I'm not quite sure. I didn't see the end of the video, but he's going to start off by saying that triangles have to sum to 180.
Stop! Spoiler alert!
Oh, sorry.
I already know what this experiment is. Unfortunately, nobody's ever going to be able to really run it. But yeah, go ahead, man. Go ahead.
Yeah, let's start with this one.
And then I'll demonstrate it.
Hey guys, Rich will Thrive and Survive, August 25th, 2018. Every now and then I have to do these videos just to show the idiocy of the trolls, or even the people that don't even think they're trolls. A long time ago, did this video here, Flat Earth, bus, Google Earth, prove it yourself. This is the key, prove it yourself. Now I'm going to lay on you something today that anybody can do. It's very easy. And, you know, just getting flooded with straw man arguments. And the reason why this is important is because people that are new to this, they don't necessarily understand straw man arguments and these other arguments that just make no sense whatsoever. Just calling, you don't know what you're talking about, you know, this type of thing, ad hominem type of attack. So anyway, in this video, I painstakingly showed how the data on Google Earth is based on flat Earth data. Not only that, but I've talked about it before, how people have come up with and actually downloaded the data on Google Earth and showed that it's flat data. And what they've done is, except for the pictures, the picture data itself has been made to curve. Now we can show, and I'm going to show how you can prove that all roads don't lead to Rome, they lead to the equator. You see, they need a basis point to bring everything back to on the globe. And you're going to be able to see, using the ruler tool on Google Earth.
Okay, Sly, go ahead.
Basis point. Understand something here. Basis point. In other words, something in which you could angle towards. The equator goes around the whole Earth, or it goes around the whole flat Earth. That's not a point. Just thought I'd throw that out there. Continue.
More garbage.
That all their data is based on not only flat data that I've shown here, but again, they have to have a central point where it goes back to, where there's a base that everything is based off of, and evidently that's the equator. And that's not just from what I'm about to show you. Again, people have downloaded this data, but people want to live in their cognitive dissonance. Now, what I did was I showed on here that there was 3 different points on the Earth that, given the distance, are exactly as if they were 360-degree angles on a flat Earth, showing that the data was taken from a flat Earth. And what you do is you...
How does that show anything?
Yeah, it's just incomprehensible.
On a flat Earth, every 3 points would yield a triangle with 180 degrees of angle sum, wouldn't they?
What?
Yeah, but that's what he's saying. He's saying that on the flat Earth it does, and therefore I think
yes, on the flat Earth it does for every 3 points. You can pick 3 random locations, and the sum of the angles inside the triangle.
Yes, I think he understands that. That's the point.
Yeah.
I think he's saying.
Okay.
On flat
But the
Earth.
question is, does he understand that that's not the case on the globe?
Yeah, I can't remember. I think he's about to say you don't get you get the same. I think he might be saying you get the same result. I'm not quite sure now. I can't remember.
Oh my god!
Which therefore you can't get the same.
Continue with this.
Obviously, you shouldn't get the same result on a sphere.
You get a ton of comments where on a globe the a triangle has more than 180 degrees, and to that I respond, and so
Stop.
Okay.
So that's an answer.
Oh. Okay, let's do the geometric proof that on a flat surface the angle inside the triangle will always be 180 degrees. That's quite easy. Let me do that in paint. It will just take a few seconds.
No, pull up your what is it, geo whatever?
I can do that, but this one is faster.
Oh, okay.
Okay. Oh, not that one. Okay, line 1 and line 2. Those are parallel. Okay. So that's just a random triangle. Okay. Nope. Wrong one. Fuck. Just to paint again. Okay, so here we have this triangle. Actually, correctly. There we go. The triangle in question is the one that I'll... What the heck? Is the one that I'll mark gray. This one. Let's take a look at the angles. That one, I guess. Okay, we can agree that this angle and this angle are identical, right?
Okay.
Okay. This angle and this angle are, let's do a different color. This angle and this angle are identical. Right?
Cool. It's always going to be that way.
Okay. Now this angle, the green one that I marked, is identical to this angle.
Right? If the top and bottom lines are parallel, yes.
Okay. And in the red triangle, on the red side, this one will be identical as well.
Right.
Okay. This angle plus the blue angle equal 180 degrees, right?
That should, yeah.
Yeah, because you have from this point here, you have this entire angle. That one's 180 degrees.
Okay.
Okay. And since we show that this angle and this angle are identical, and this angle and this angle, the two red ones are identical, that means that the blue angle plus this green angle plus the red angle are 180 degrees in every circumstance.
Job done.
Therefore, on a flat surface, the sum of the angles inside a triangle is always 180 degrees.
Now,
I think he knows that.
I have Google Earth up right now, and we're going to do this with some real life points here.
Let me share you.
Okay, first of all, I am over Frankfurt right now. So let me draw a Frankfurt line from Sly.
I have to ask it which Frankfurt.
Frankfurt on mine.
Okay, there we go.
So from Sly to Surf Perzel, somewhere there. I just picked the middle of Berlin. I don't know where she lives. Okay, so that is 49.06. Or actually, let me write these down here. Come on. 49. Oops. Yeah, I can spell real good here. 49.06. Okay. Now we'll do the next one. Oops. We'll go from Surf Perzel down to Geo, somewhere in Nuremberg. Okay. 206.30. Okay. And then we'll go from stop that. We'll go from Geo back over to me. So that is 294.20. 4.20. Now, let's go ahead and put all three of those angles together. Oops. Across a plane and see what happens. So I need, first of all, I need a line. Let's see. So, yes, for everybody who always likes to argue that I never use the snap. There we go. Okay, so turn the damn snap bullshit off. Okay, so let's rotate this. Hold on. What are my three angles? 1 to 49, 49.06. So rotate. Which angle am I looking for? Right there. Okay, so back. 49.06. Oops, wrong axis. 49.06. There we go. Minus 49.06. There we go. So there's that. Oh shit, I didn't grab the lengths, did I?
Yeah, that's pretty important.
Yeah, it is important, isn't it? Hold on a second.
Should we come back to you?
Yeah, give me a second. I didn't grab the lengths. That was pretty dumb. Okay, so going back to Berlin. Sorry.
Well, should we go on the video and then you can work on that one in the background?
Yeah, go for it, man.
Well,
Go for it.
Sounds like a plan. Okay, there we go. By the way, can you still hear me?
Yep.
Oh yeah, we can hear you.
Great.
The rumpus in the internal chat.
Oh yeah.
Okay, let's continue.
And so this should never be true. These should not be equal, but yet they are. If people would have taken the data that I showed on here, you would have found out that it is indeed not matching what you would find here on a globe. Google Earth takes flat data, and anyway, in this video, Flat Earth Bus, Google Earth, Prove It Yourself. Well, this is an oldie, but a good one. April 10th, 2016. Third of a million views, almost. Pretty good, huh? Anyway, here's a comment that triggered all this. Declan Gilmartin, a person with his head up his arse. The video is totally incomprehensible. I think flat earthers' main problem is that they do not understand how enormous the Earth is compared to the size of a human being. They also do not understand the difference between water and land. They don't realize that you can see the ISS with the naked eye. Flat earthers are children who are jealous of the achievements of the adults. Again, someone with their head up their arse. Okay? Plain and simple. Nothing but ad hominem arguments from actually a mental child.
I mean, by calling somebody with their head up their arse?
You're a mental
Yeah,
child.
stop. Any argument yet? I don't see anything.
No.
No, it's nothing.
Child. Let's see how much of a troll channel it is. Oh, they've got one person here.
Stop. To the people in the side chat. I know it's kind of useless, but just to fuck Mr. TNS, would you maybe subscribe to this guy? That would be awesome of you.
Anyway, ad hominem remarks. I've said it before. Block user. See.
Stop. I'm being blocked by Mr. Thrive and Survive myself, and I think at this point, this is a badge of honor, isn't it? It definitely shows that you're doing something right.
Shit, I've been blocked on his channel for over 2 years.
Yeah, the reason I've been blocked recently, actually, just maybe 2 months ago, more or less, was that I developed the pattern to actually post very lengthy comments under his videos, pretty much debunking every single point he made.
Yeah, that's what I did.
Yeah, and at like the third or fourth attempt, or the third or fourth time I did that, he just blocked me for obvious reasons.
Guys, I just remember when I proposed a slide to do the experiment with the single rotation of the camera.
Mm-hmm.
I just did that, and I can show you my results right now.
Go for it.
Well, let me see here. Hold on a minute.
Screen share you. Let's link your screen share.
All right.
Obviously, you have to screen share your screen.
Yes.
There we go.
I will show you what I did. I made first a clip of the object I want to show. This is a picture, of course, a map of the Earth, not a very accurate map, but still, it is a rectangle, as you can see. Right. So now
it's effective too. It's oriented strangely.
Yeah. But I did it on purpose because I'm about to show you. But now I'm going to rotate my camera on a single axis, of course, a bit crudely, but still it serves the purpose. Now we're on a single rotation. As you can see, the top and the bottom of this picture is going to be distorted like that. See, and if you do this for a panorama, let me see here, a panorama. Hold on, panorama picture.
I think you just stopped screen sharing.
There you go.
There we go. Okay.
I was trying to find this. And this is when you get when you take a panorama picture on a single axis of rotation. As you can see, the top lines are curved inward, and the bottom lines are also curved inward. So this is the same effect that you see with the stars on a single axis of rotation.
Yeah, but he's going to say, you know what he's going to do? He's going to misinterpret that as it actually expands towards the middle. I know what you're showing, but he's going to actually say that that's expanding.
Expanding how?
Because the picture in the middle looks bigger than the ones on the left and right.
I need to address something in the side chat just really quick. John Watson, if you want to join, that would be okay. You just have to write me a message somewhere, and if you want, I'd actually be able to kick the other people out, so we could have a 1 versus 1, if you insist.
John Watson wants to talk to you.
Apparently, he seems to be a little bit confused about the fact, or angry about the fact, that flat earthers. I think he's talking about the person that shall not be named here. Has his link open all the time while we currently don't.
Well, here's the thing, Gio. John Watson, one thing that he loves to say is that, what do you call it? You can't photograph things if you don't know what they're made of.
Oh, God.
Classic.
Okay. In other words, the argument that he wants to have is because of star trails, because you don't know what stars are made of, or you can't empirically prove what stars are made of, you personally, then photographing them is a waste of time.
Okay, can you stop share? Can you stop presenting me?
Oh yeah, sorry.
Yeah.
Sly, are you ready with yours, or shall we continue with the video?
Almost there.
Okay, so let's continue maybe for 1 more minute with the video. So let's see.
And does my presentation count as a debunk, or?
In a way, yeah.
Perhaps I'm wrong. Perhaps I didn't take the.
You can stay with the children with your little storm videos. So let's go back to where we were, and let's go and prove that something is desperately wrong with Google Earth. Now, you don't want to. This is a little complex. It did take most of the night. Dave in the UK and he mostly found these 3 cities that were equidistant, over 2,000 miles apart, and you could connect them using. The geometry of a flat Earth worked, but not on a globe. And I guess people miss that. Of course, they want to miss it. So let's get into some really juicy stuff here, shall we? Now, first of all, I didn't discover this. My understanding is this was first shown on a Globebusters show. So credit to them if that is indeed where it came from. I have no reason.
I just like to point out it's not actually made any point about some of those triangles.
Stop. Repeat.
Yeah, he's moved on to a different subject without actually coming to a conclusion about this addition of the angles of an internal triangle. He hasn't come up and said, "Oh, look, on a sphere."
I think he's doing that right now.
Well, you think so, but as I remember, he doesn't. Okay, carry on.
Okay.
Warrior. So anyway,
I think I need to repeat the last 20 seconds or so.
Sorry.
Let's go from here.
I didn't discover this. My understanding is this was first shown on a Globebusters show. So credit to them if that is indeed where it came from. I have no reason to doubt it. And it was brought to my attention by Sleeping Warrior. So anyway, you need to use Google Earth Pro. I don't think the one online using Google's browser will work. Maybe it will. I don't know. I just know you're going to have a problem here. Now,
stop. First of all, he's right about one thing. The new browser version of Google Earth is shit.
We know that if you had it's 090 degrees. And if you had due west, what is that? That's 270 degrees. And if you had due east from a certain point and you go, let's say, 2,000 miles, and then you turn around and head due west 2,000 miles, you should come back to the exact same point, correct? That is if the data is correct. If it's based on a globe and not a flat Earth. Let's see what actually happens here. Let's pick the tip of Michigan up here, someplace where we can actually recognize. So I'm going to click on there. And then I want you to notice over here, this right here, this will tell us the compass direction, the heading we are going in. All right, so let me get this.
Stop. Prediction. He's mixing up the grand circle with actually moving east to west.
Yeah.
Also, I need to retract my presentation because it doesn't count as a rebuttal, because the distortion that you saw with the map is caused by a relative distance between the sides of the map and the middle of the map, and not necessarily the same thing with what's happening to the stars when the Earth rotates.
Yep, you're right.
My bad.
Just to start, I can get it to work. Close enough. You can see where you are in Michigan. And see, as I go down south, you get it to 180 degrees, roughly. This isn't going to be exact, but it's close enough. That's 180 degrees. That's south, correct? North towards the North Pole would be up here, right about there. Due west would be, let's see, somewhere in here. Let's see if that looks right. There you go, 270. And then 090 is due east. So let's go ahead and go across the Atlantic. And we are going to, doesn't matter what the orientation of the Earth is, because due east is due east. And let's pick some place in Africa. Pick a place a couple thousand miles apart. Let's see if we can pick somewhere in here. Let's get to 90 degrees. There we go, 90 degrees right there. Let's go a little bit further. See where this conjunction of these two countries are here. 3 countries right here. Let's get it as close as we can to 90.
Apparently he doesn't know what an enclave is.
Details.
Yeah.
There we go. That's very close to 90, isn't it? Now let's go back over and look. So we went from Michigan to this part in Africa, right? Does that look right? Does that really look due east? Well, let's go.
Stop. Yeah, he met exactly my prediction. When you go to Google Earth and you put out the heading, what's happening is that it will show the heading at the starting position. Obviously, the heading is going to change. Let me demonstrate this. Share my screen. Okay. So let's go. Let's do the same that he did. Go to the top tip of Michigan, northern tip of Michigan. And then head east. So as you can see, by the way, this is 2 countries. This small piece of land over here, that's an exclave actually of Angola. Do this correctly, 90. Save that. Name is irrelevant. Now let's go to any point on that line. Say from here. Obviously, the heading is not the same. You see now it's 131 degrees instead of 90. And when we do the same thing further south, heading changes to 135 degrees.
Yes, and this is what I was explaining earlier, saying I wasn't fully understanding how in Google Earth can you say I wish to go at 90 degrees heading and then keep the heading? But of course, obviously, what this is doing, of course.
If you keep the heading. Sorry.
What this is trying to do, of course, is if you put 2 points anywhere on the Earth, it tries to draw a great circle. Whereas, of course, if you don't like that is almost on the same latitude as England, for instance, if you said I wanted to follow a course of east, going exactly east from the Michigan there, you'd end up somewhere, okay, perhaps France. But there's no way of doing that in Google, because if you draw 2 points on this, it tries to draw a great circle. And of course, it's not a great circle going from Michigan to the UK. If you did that, it would then draw one that
would go north first.
Greenland or something.
Yeah, that's why the polar route is a thing for airplanes.
Yeah. So I was then thinking, how So I was thinking, how on earth in Google, this is a bit that's confusing me, how on earth in Google can I say, I wish to go along this heading? I don't think you can do it, because it insists on drawing great circle lines between any 2 points. You can't actually work out what the heading is if you wanted to take a heading and just stick to the heading, which comes back to this point that was made on bloody Nathan's, whatever was that Issa guy, or no, was it, Issa, about the headings, and that you take as a bearing if you wanted to sail somewhere, whether you stick to the same heading and you cross the meridians, as they call a run line or something. And he thought that effectively the headings worked on a flat Earth as well as a spherical Earth for 900 square kilometers. I mean, he got confused about what bloody square kilometers were, square miles were. And they didn't appreciate when you're doing a heading, a difference is actually very little difference on a heading between a spherical Earth and a flat Earth. So it's all linked into this. But yes, so anyway, the point is, I don't think in Google you can actually say, here, take this heading, and then it will follow that route. It always makes you insist you set a point down, and then it will give you the great circle, which of course will not be the heading you're looking for.
Obviously, if you follow the heading, you will stay on the same. Well, if you do a heading of 90 degrees, for example, meaning you're directly eastwards, and you keep that, you will stay on the same latitude all the time.
Yeah.
But when you go to the North Pole, you can actually see why that is a fucking gigantic detour, right? So you would stay going east, going from here to there. You would take this route instead of going directly over the pole. Obviously, this problem is worse near the poles. It's not as bad when you're getting closer to the equator, right? Because the grand circle at the equator is the equator, for obvious reasons.
But it's quite bad going from Michigan to the UK. So, I mean, there's no way in Google saying, here, what's this heading? Where will I go? So if you're at Michigan or, say, nearer probably Newfoundland there, which is on the same latitude, and they said take a heading east, there's nothing on Google Earth that lets you do that. You have it just draws great circles between 2 points.
All this tells me that flat earthers can't navigate. Surprise, surprise.
It is because the heading, and it does mean to say you'll come into the heading like you were demonstrating, Gio, that when you draw between that place in Africa, wherever it was, the Angola enclave and the Michigan, you will arrive at that angle at Michigan. But of course, the heading
actually, in this case, you will start at the angle in Michigan.
Yeah, whichever way you want to do it. Whichever way you want to go, if you start off with a little enclave and then end up in Michigan, you'd have the reverse of that angle.
Yes, exactly.
But so the odd thing is, although that angle, you don't maintain your heading in Google Earth, basically, as Gio just demonstrated, between 2 points, which is basically a bit weird, but it's how it works.
Okay, so let's continue. More garbage.
So 270 degrees back west. See, everything here is taking us to the equator. We've crossed the equator heading due east.
Didn't he think about maybe going even further? That he would get further away from the equator again?
Oh, this is the basis, though, Gio. This is the basis he was talking about earlier in this video.
Doesn't he understand that whenever you're doing a grand circle, at some point you're going to cross the equator?
Yeah.
Oh God.
It's always the case, unless you are traveling over the equator itself, you're always going to cross it at least 2 times.
Yes.
Yeah.
Oh dear.
That shouldn't be, should it? Maybe we need to do this again. Let's straighten the orientation up before I come back here, because people are going to say, well, the orientation isn't right. No. That should have nothing to do with it. Let's start from the Chesapeake Bay area, northern Chesapeake Bay, right here, and let's head due east. Keep sending me towards the equator. Why is that?
You're gonna hit it eventually.
Oh God.
A flat earther confused about math. Is anything new?
It's confirming the stereotype.
This is painful.
Yeah. It's like a kid. What's also a good example? Being amazed about how an adult makes the thumb go off one of his hands. Like, how does he do that?
You do that as well in Holland as well, do you? That's so funny.
Yeah.
So same tricks get around.
Okay, Sly, is your model ready, or should we continue?
Go ahead and do one more step. I want to put a little bit of extra to this.
Okay, then let's continue.
The further I go, the more it's going to be off. Let's go only, maybe we can go to the islands here.
Did you say islands or Irelands?
I think it was island.
Yeah, islands. I think he's talking about going to the Caribbean now, isn't he, or something?
No, he's
No.
heading towards the Azores, I think.
Oh, sorry,
The
there's
Azores, yes.
90 degrees is right about here. I don't want to go too far. You should already see there's a problem here. But when I get to 90 degrees, like right about here, when I head back due west 270, I should head right back where I'm at, correct?
No,
Let's see what
no. Let's do this live again. Obviously, it's so easy. Why doesn't he understand this?
You know what I?
It's even easier to see when you draw in the coordinate grid.
I can answer the question. He is stupid.
Okay, so let's see. Here's
I'd like to add
Chesapeake Bay.
I'd like to add something there. A minute ago, he was saying that he would seek Dr. Zach's counsel. I'd like to remind him that Dr. Zach actually put out a video about this, saying that everybody needed to stop. All flat earthers needed to stop using the line measuring tool incorrectly to come up with incorrect answers to what they think that it's showing. Dr. Zach actually put out a video on this. I even complimented him on it because it was the first thing that he put out that was right. But Rich, go over to Dr. Zach's channel. As a matter of fact, let me go ahead and check and see if the video is still there. Just real quick here. Hold on. Hold on. Dr. Zach. And Dr. Zach. And videos. I even know what the thumbnail looks like. Right here. Go over and watch this. It's called Flat Earth. Is Google Earth wrong? Now, you can have all the discussions you want about the Earth and all this, but you're talking about a problem in basic geometry. Has nothing to do with the Earth or not. Has only to do with geometry, which actually Dr. Zach does explain quite well in this video, that what you are doing is you are being an idiot with the measuring tool on Google Earth. Just thought I'd point that out. Feel free to go watch it there, Rich. You know, it's right here. It's been out for a year now. As a matter of fact, I think it came out shortly after Jeranism did the same stupid shit. And he doesn't mention him in here, but you need to actually go over and watch that video there, Rich, because it explains everything that you're getting wrong about this. Good. Sorry.
Okay.
More garbage.
Yeah, more garbage.
the data does for me. So we're going to start here. It'll allow me to do it. All right, notice this place here. I'm going to clear it. We're going to start here. Come on. Interesting. There we go. Now let's get 270. Whoops. See, here is, 310 degrees to get back here. Well, let's go 270 due west. Where does it take us?
Is he doing back azimuths?
Right there. Wow.
What's like?
Is he doing back azimuths? As in, I'm not looking at it right now because I'm putting together the last bits of this model, but is he actually doing the thing where you draw a line across Google Earth and it says it launches at one azimuth and then he's drawing the line backwards and it says it's at a different azimuth, not a perfect reversal?
No, he's checking where he will end up when he starts at 270 degrees heading.
Okay.
And obviously he ends up somewhere in the Caribbean.
Yeah.
Well,
Okay.
and if you extrapolate this, then at some point you will cross the equator somewhere in the Pacific Ocean.
Oh, heaven forbid.
Wow. Here's Ecuador. Here's the equator right here. It takes us back to the equator. Shall we try another one? Maybe it's just an anomaly in the Atlantic. Could be. Let's try the UK here. Let's clear it out. Let's try the southwestern tip right here of the UK. And let's head 090 degrees and see where it takes us. Oh, it's already taking us due east down to the equator. How can that be?
Pause for a moment. So he's going at first directly west and continues the circle path onward. Yeah. Or east in this case.
Doesn't understand that the latitude, that the longitude, no, latitude.
Yeah,
the latitude line and the grand circle aren't the same thing.
Yeah, exactly. But you won't stay on the latitude lines when you are going west or east. That is retarded.
But even if that's off, if we had 270 degrees now, it should take us right back to here.
Oh, no, it won't.
No.
So let's start here. And let's head back to 70 degrees. Oops, it's 319 degrees. That's not the opposite.
I think we should call this video. I think we should call this video Mr. Thrive and Survive Can't Globe.
Yeah, that's about it. Oops, shit.
Or we should call it Drawing the Lines.
Ooh, way down. Ooh, look at this. It's even more off. Guess what? All roads lead to the equator.
Duh. and back again. Imagine that.
You can do this. Take a sphere or some sphere. You can even take an apple or something and draw a hypothetical equator around it. Now, do the same thing what he is doing right now. You will always end up at the equator when you draw another line like that. Oh, God damn it. More garbage.
I mean, this is so ridiculously stupid. It's incredible.
Yeah. It's embarrassing at this point.
The line must be drawn here, this far, no further.
I have a better analogy than the thumb magic trick. Let's say you have a child playing in a sandbox and he is drawing a circle around himself with a stick, and he's surprised when the circle ends at the same point where it starts.
I want to say earlier, I was talking about the field of view of a 50mm lens. Actually, I think someone pointed out I was made an error there. It's actually it's near a 40 degrees total field of view for a 50mm lens. I think I said 60 earlier, so yeah, I was slightly overdoing it.
Here. And once again, Flat Earthers,
isn't that incredible?
That's how you do it.
And yet this date is perfect for a globe, isn't it? Wow. Let's go all the way to South America. See where it takes us, 270. Halfway around, huh?
Okay.
Wow.
Look at my thing here real quick.
Yeah, let's switch to use live. Screen sharing you now.
Okay, so basically what I did was I made this triangle, okay, which was between a point in Frankfurt, point in Berlin, point in Nuremberg.
Stop before you continue. Did you actually take 6 measurements? You need 6 angles for the reason we just demonstrated.
Well, the back, I'm going to show one thing first, at least.
Okay, go ahead.
The back azimuth thing, it's only off by a very small margin given the short distances that I used here. But anyway, what I did was I got those measurements and those angles. Here's the azimuths that they took off in a clockwise rotation, okay? Meaning that from Frankfurt to Berlin, from Berlin to Nuremberg, from Nuremberg back to Frankfurt. These are the distances, and these were the takeoff angles. Now, if I match up Frankfurt to Berlin.
Hold on quick. I want to respond to MrThriveAndSurvive. He said, send me 10 grand for the Antarctica flight. No, we are going to send you the ticket. not the money, if we are going to do it.
For obvious reasons, it's not a good idea to send flat earthers money.
Yeah, they will burn it.
Okay, but anyway, leaving out from Frankfurt at 49 degrees. Okay, 49.6, excuse me. Coming up to Berlin, then leaving Berlin at 206.3 over the distance that was stated on Google Earth, and then landing at Nuremberg. Nuremberg, also at that very same point, taking off at 294.2. Look, it misses. That means no, the triangles are not based on flat math. Now, if we were on a sphere, this right here, all of these would have a very slight bend to them, and it would bring it right back to its location in Frankfurt.
Can you actually simulate this?
What's that?
Bending
Can you put it on the sphere?
Yeah, that's what
I could. That would take a little bit more time.
Yes.
I don't, because AutoCAD would actually be better for that. I don't have AutoCAD.
Nice demo though, Slide. That does show exactly that it does not match.
Wait, hold on a second. I got to get that distance in there. I didn't put the distance in there the right way. 294, or I didn't put it on at all. 294.21. Oh, that was at 188.3. 188.3.
Right, is that the distance from? Yeah, I was about to say 290 seems a bit far from Nuremberg to Frankfurt.
Yeah, and so
190 is much more realistic.
Yeah, and let's see. 188. I did this in meters. 300. Look, oops. There's a problem there too, isn't there? They don't match. Sorry, Rich. You're wrong. It's not based on flat math. It is based on math across the surface of a sphere.
The only problem is that you've got an error here, and the only way to prove your point is to do what Gio said and to put it on a sphere and then show that it works, because it could be you've made a mistake. So unfortunately,
because that's where I got the data from.
Yeah, but your model you've constructed, I mean, they could claim you haven't put the angle in correctly, or you haven't put the mod length in correctly. So you've just found an error. You don't know.
Well, that's why I did these at very specific lengths and very specific angles.
Yeah, I mean, it looks right, but they could claim, the fact you found an error doesn't prove the point that it does work. But I suppose we could. They can easily claim you've made an error somewhere in your diagram. That's all, and it would show up as an error.
Sly, can you do me a favor and pick up Google Earth again? I just discovered something that hurts me a bit.
What's that?
Obviously, your Google Earth is in English.
Yeah.
Take a look at the way the Erzgebirge is named.
Erzgebirge Mountain.
Yeah, that's like a double tap. It should either be called Erz Mountains or Erzgebirge.
Yeah,
but not both.
But people who speak English don't know Gebirge means mountains, man.
Yeah, we don't know Berge means mountains.
But aren't they then just calling it
something
Erz
you
Mountains? That one is just redundant.
It's the Erz Mountains.
Yeah, exactly.
Yeah. But nevertheless, the
But this is my point. It's like they could say if you made an error, all that would show that you've shown is that you could either be the cause of what you've done is an error, or the fact that it's a problem. You don't know you haven't made an error unless you've put the same stuff you've got there onto a sphere. But I mean, it's obviously it's unlikely. It's pretty simple to do. But I'm just saying that in itself.
Well, the simple point that I'm making here is that here I am modeling it out live on a sphere. Okay, there's nothing flat about Google Earth. Okay, I am modeling it out on a sphere. The ruler tool is a surface measurement tool. Okay, which means that it is measuring the surface distance between points. It is also, as is the point of contention, it is also launching off at specific azimuths from each location along a great circle route around the Earth, regardless of what direction that you point it. Okay, so this is the modeling of it on a sphere. This is a 100. Hold on a second, Rumpus. This is a 100% 2D version of the exact same measurements. However, as you notice, they do not conclude a closed triangle. So therefore, the error that's being shown here is, number one, Rich is saying that they're using flat math to do this, whereas flat math is obviously showing a different result. That's the point that I'm making.
Yeah, I suppose if you clicked on you have clicked on the lengths and demonstrated those are the right lengths and the angles are the right. That's all you need to do to make sure they understand that you've got it right. I suppose that's all I'm trying to say.
Okay, from Frankfurt to Berlin, the points that I did was 423,860 meters, which is 423.86 kilometers.
Yeah.
The point that I did from Berlin down to Nuremberg is 387,270 meters, which is the measurement that I got, and that is also 387.27 kilometers. That's this one. As you can see, this one is a little bit longer than this one, as per the numbers. And then from Nuremberg, as we just did live here, from Nuremberg to Frankfurt is 188,300 meters, which is 188.3 kilometers.
And the angles you got as well. Yeah.
The angles are all set up in here. That's why I put these cute little compasses on them, because unfortunately AutoCAD has a wonderful little way to lay out compasses between things. Unfortunately, 3ds Max is not built for architecture. It's more built for animation. Yeah. So therefore I have to actually drop them in myself.
Okay,
guys, I just discovered something amazing. Let me show you.
Sure.
And so
go ahead, screen share you?
No, go ahead. Yes, thank you. If we start from the America and go west, we enter the equator. And when we go from Africa to the east, we end up in the equator. How does it happen? I don't know. Do you?
Yeah, this is the amazing thing on this is if you take that bearing. Yeah, I mean, this demonstrating itself. That bearing would. Yeah, going west on this thing would take you to the South Pole, according to this map.
Yeah.
If you go west from anywhere or east.
But west is west, not south. So this proves the flat Earth.
I mean, just look at. I mean, how can they believe? I mean, if you go west from that position you've got in Michigan, or east, actually you've got it east, haven't you? If you go east, if you carry on going east indefinitely, you will end up at the South Pole.
The AE map in itself is so ridiculous. Just look at the size of Australia.
I mean, you were disagreeing with me, Nestle. I'm just saying, if you go east, you follow that yellow line you've drawn down from Michigan, you just carry on going, you will end up at the South Pole. That doesn't happen.
I was parodying his line of logic to disprove the Earth, the flat Earth in the same way.
Okay, so let me show you the last thing of what he's probably not going to show you in this video. There's the whole.
There we go. Okay, Sly.
There's the whole issue of walk 10,000 kilometers, turn right, walk 10,000 kilometers, turn right. You do that 3 times, you'll make a triangle, having done 3 90-degree angles.
Yes.
Easiest way to show this is obviously if you were to go at the equator and you walk north 10,000 kilometers to the North Pole. Okay, you got that. Okay, now down at the equator, if you were to turn then, let's say in this case, due east. Would you stop fucking with me? What do you call it? If you were to turn due east.
That's west. There we go.
Yeah. If you turn due east and go 90 degrees around the Earth, okay, you've walked another 10,000 kilometers. And then you turn due north from there, and you have another 90-degree angle. That is the whole discussion of triangles on a sphere. Okay, now I had to figure out what the parameters were of that, because you can't do it smaller than that. Okay, you can only do this 90-degree, 90-degree, 90-degree when you use 90 degrees of the sphere.
Yeah.
And it makes a perfect triangle. Well, it makes a triangle, but with 3 exact right angles.
Yeah.
And that's the part that most flat earthers don't get.
Could Nestle do the same thing on a flat Earth? Go to 10,000, then do 90, and then do.
All right.
No, that would still work on there. No, because going west,
No,
then
it won't work.
Oh no.
yeah, because going east won't go along the equator. Of course, going east on their thing will. Yeah, I mean, for Christ's sake, going on their system, going east doesn't go along the equator. If you're on the equator, going east, it will eventually take you. If you maintain that angle, the heading you start off at, you just go to the South Pole.
Right.
No, according to this map, if you want to go from here on the equator from here to there, you should take a northeast direction.
That's not the worst thing. Look at the distance. It should be square root of 2 times 10,000 kilometers. So
Yeah.
14,100 approximately.
Yeah. At this distance, this yellow distance should be about the same length as this distance from the equator to the North Pole. And it isn't, according to this map. There's so much wrong with this.
Yes.
So much it just doesn't even start. If you just maintain your heading going east to west, you will not follow a line of latitude. Just
Well, except for if you are directly on the equator, for obvious reasons.
oh well, no, not if you maintain the if you follow the same direction, you will. Well,
yeah, but you would have to walk a curve to the left. It wouldn't be a straight line anymore, as it is on the sphere.
Yes.
Which is the exact point.
Okay, more garbage.
More garbage.
Takes us even south of the equator. Looks like it's a due east-west now, doesn't it? Yeah, it is. It is due east-west, but it's not from where we started from. See, the data is skewed. All the data, I'm going to say it one more time, was downloaded. All the data is based.
I just want to point out, every time when he when he came close to the equator, he would stop and pick the new position as the next one to start from. So of course he's going to get closer to the equator. If he continued across the equator and then picked the random location afterwards, so in the southern hemisphere, then he wouldn't be doing this. Right?
Yeah.
There we go.
Based on flat map data. The only thing that is not is the actual pictures, which are curved. You can see it in the data where the pictures are curved and placed on here so that you think that you're living on a spinning ball. But all the data, just like I showed in the other video here, let's flip back to that, shall we? So now for the incredibly lazy and ignorant and those filled with ad hominem remarks and comments.
Stop. Irony. And a little bit of a double standard here. Do you guys still remember how this video started?
No, the stupidity was too much. I already forgot the first part.
He was talking about this Declan guy with the 1 subscriber.
Mm-hmm.
So, and what was the first thing he said about him?
I don't know. I don't remember anymore.
Okay,
I think
so
it was
12 minutes 01. So let's see.
And that he only has 1 subscriber, I think it was.
Yeah, something like that.
But a good one. April 10th, 2016. Third of a million views, almost. Pretty good, huh? Anyway, here's a comment that triggered all this. Declan Gilmartin, a person with his head up his arse.
Stop. So, and now going back to 11, what was it, 50?
Yeah, at 12.1.
Yeah, but I need to play the last few seconds.
So now for the incredibly lazy and ignorant and those filled with ad hominem remarks and comments.
Stop! Do you notice it now?
Oh, yeah. Hypocrisy.
Yeah, massive hypocrisy, double standard.
Yeah.
Okay, let's continue.
If you would actually do the work yourself instead of just calling people childish and not understanding things, you'd see.
I just want to reflect on that for 10 more seconds.
Mm-hmm. The dramatic pause.
3, 2, okay, let's
that
continue.
these things are actually true. And pointing out the fact that there's 180 degrees on a flat surface and more than 180 degrees on a globe makes no difference if the globe data is based on flat data. That's why flat 60 degrees at each angle works with the distances on Google Earth.
Yeah, it works for this particular case, but not for any other case. That's what he's not seeing. And actually, I don't think the triangle that he's showing is correct. It should be more than 60 degrees, much more actually. Because obviously you will have 180 degrees of angle sum when you're working on the flat plane. That means that when the distances are very small, when you have bigger distances on the sphere, the angles are gonna get bigger automatically, right? So I don't think there's a chance that the diagram that he's currently showing with 360-degree angles is correct.
Oh no, I don't know. He's just drawn it. Yes, he's just superimposed a rect, whatever it is, equilateral triangle on top. Yes, he hasn't bothered to measure that. Yeah.
Yeah. Do we actually want to measure those?
Yeah, it might be interesting, wouldn't it, to see what?
Okay, let me do this.
Because like Sly was showing, that's probably quite close to being 90. Actually, that's almost like an eighth of the. Perhaps not.
Okay, let's see. So we have one somewhere on the Sinai Peninsula, I guess. Somewhere approximately here.
Sumatra, and then you got
no,
the top of the Red Sea.
Yeah, that's Sinai. This peninsula here is called. Oh, actually, I'm not sharing my screen.
Yeah, not sharing them.
There we go. Okay, so this peninsula here in the Red Sea, that one's called Sinai. And he's going up to
Sinai, right? Yeah.
Sinai. Sorry.
It's okay. It's okay.
Dialect kicking in here, or accent. To approximately there.
Something like that. Yeah, that was about that. I can't compare again. Let's have a look. Yeah, it's just sort of. Yeah, let's have another compare with your thing.
No, a bit further.
Yeah, a bit further over actually. Yeah, a bit
right here.
I would say slightly more up, but never mind.
No, I think it's approximately right.
Okay.
Let's save that.
That's not bad actually.
So the second one that. What the heck?
While you're doing that, I'll just say someone is hassling me about the 40 degrees I mentioned for the field of view on the 50 millimeters, and saying I should look at the table. It says 46. Well, actually, I was looking at another table. It said 43, so I was just approximating it down to 40. But yes, that table they've been offering does say 46, but I was using another table which says 43.
So that one is somewhere in Sumatra, approximately here, maybe.
Yeah, it was Sumatra. Yeah, that's right about there. Yeah, I mean, we're going to look at the picture again. The other one.
And then the third one.
Yeah, it's middle of Sumatra. Yeah, you do. Yeah, yes, you're right.
Okay, and that one's going back to here. Okay, so let's look at the angles now. So from here, 26. 101, so 101 minus 26, 75 degrees here. So not 60, 75 degrees.
Yep, so that was, yes, not.
Obviously, I'm just eyeballing this.
Yeah, that was 76. One of them was 76, right? Okay.
So 293 minus 216. 77.
77, right? Okay. So we've got a 76 and a 77.
Yeah. And now this one is going to be a bitch. Because obviously we have to add 360 to this. So 14. 300. So that's 60 plus 14. So 74. Right?
Very good. Yes.
Okay, so 74 plus 7. 74 plus 77 plus 76. That's 227 degrees in total.
Yeah. So all he did was just drew an equilateral triangle on top of the Earth. Yes, he didn't.
Yeah, he's wrong about his 180 degrees.
Yeah.
By a big margin, actually.
So yes, and that's the point I was saying. He never got round to making that point. He just simply drew it on there, and he never then showed that it is not different on a sphere. And now we've just shown that it is different on a sphere.
Oh God!
So we've made the point that he failed to make at the end of his piece, which is the point I was making earlier.
Yeah. So let me show this actually again. Oh, there we go. So this was the diagram he drew. with 3 points, one in Siberia, one on the Sinai Peninsula, and one in Sumatra. And he said that all those 3 angles would be 60 degrees. Obviously, as we showed, they are not. They are closer to 75 degrees. So he's wrong on that.
Yeah,
if you make the initial angle 60 degrees on each side, the lines will not be straight. This is idiotic.
Yeah, and the lines that he's drawn in aren't even grand circles.
Yeah, exactly. They would not be straight. That's what I'm saying.
Yes. Yeah. Oh God, so painful.
There's so many things wrong with that diagram.
Yeah.
Okay, more garbage.
Proved. I mean, by his claim was going to be that it should still be 100 coming to 180, but and he didn't get around saying, making the point that it was, and therefore it would have to be flat. But no, he just demonstrated it's not. He's just invalidated the flat Earth claim that he made. I mean, it's just extraordinary.
How much of the video do we still need to go through?
3 minutes and 8 seconds.
Let's team roll do this last part, I think.
Yeah, let's see.
And if you take the time, and it does take time to do it, you can find places over 2,000 miles apart. Draw your 360-degree angles as if it were flat, because you're not really drawn on a globe here. It's a flat depiction of a globe, isn't it?
God, man. Dat made my brain hurt.
Where's the bleach?
Let's bleach. Pew! Pew!
Let's try to debunk this correctly. So,
there's bleach.
Okay, so this is approximately the same view that he has in his diagram, quote unquote.
Yeah.
Now, obviously, I'm looking at this on the 2D screen. But what he's forgetting is that the model itself is still three-dimensional. The only problem that we have is that the graphical user interface basically is two-dimensional, right? The entire calculation that is done is still in 3D. Only that I don't have a 3D monitor that can represent it.
Yeah,
these 60-degree.
We are not. Go ahead, sorry.
Yeah, these 60-degree lines may actually be correct if the line, for example, in this 3D model would be going through the planet, right?
Yeah.
If you were in the 3D space, you would have a direct line between the 2 points. It would obviously go through the planet. And then those 3 lines would be 180 degrees in total, right? Because 3 points are automatically in the same plane.
Yeah, they're in the same plane.
Yeah, we don't have holograms yet. We only have like 2-dimensional computers screens.
Correction, Neslik. You can actually get a 3D version of Google Earth for the HTC Vive. So that's awesome.
For the how is it called? The
virtual reality glasses.
Yeah, for the VR glasses or something like that.
Which I cannot use because my glasses are too thick and too big, and I can't like put this thing on, and I'm actually too short-sighted to see anything without wearing my glasses.
Yeah, but regardless how you represent it, it's still in 3D.
Yes.
And you can't simply lay over a 2-dimensional figure on this.
You know what would be awesome? Fuck, what's the English word for this?
Try German.
Yeah.
That won't help. I just don't know the word for that. Like those, do you know those pictures where you have to cross your eyes a little bit to see a 3D?
Yeah, that's a stereogram.
Stereogram, thank you very much. Yeah. That one with Google Earth, that would be cool.
But the definition would be crap.
Yeah, the resolution would be shit. I mean, you would have to have two spheres, really like one here, one there, and then you could kind of do it.
Well, no, wait. Maybe it's not a stereogram. A stereogram is where you have a seemingly repeating pattern all over the poster or picture.
Yeah, but it doesn't need to be repeating. If you just have 2 pictures that are taken with slightly different angles, you can actually simulate 3D.
But then it's not a stereogram. Hang on. I dove into that kind of stuff ages ago.
I thought that was a stereogram.
No. So the word for this is stereoscopy. Stereoscopy.
Oh, yeah. Stereoscopy. Right.
Yes, and it also works for 2 pictures.
So, gentlemen, I got to get dinner time.
Okay, well, see you, Sly. Thanks for joining again.
Yeah, great stuff, Sly. Great demos.
Ciao, ciao.
Yeah. Bye.
That was...
Cheers.
Okay. Let's continue with the garbage, shall we? Oof.
Will show
Exactly.
that all the data is flat Earth data.
No.
You're just being fooled because they wrap it around. And if you take the time to go up here to the globe, to the pole areas, you will find that there's segments, little teeny segments all the way around where you can see they've meshed it around to make it fit, and there's no actual real data. And by the way, there's 15% roughly, give or take a little bit, extra data that they're hiding from us, especially in the South. One of the
What does he mean by extra data that
Yeah,
is hiding?
who's hiding? Where is
okay.
this data? What evidence has he got for it? What the hell's going on here?
It's a conspiracy, man.
Is he saying that there's extra high resolution images that was taken but is not available in Google Earth for some reason?
I think he's referring to the glitches that happen at the North and South poles, because like you have the singularity problem with the math that happens at that place.
Does this guy have no idea about how to present an argument? You present some evidence, some citing something, and then, but just go. Well, I suppose he just goes with emotions. I suppose you have to with a flat earth. You have to ignore evidence. Oh, God, still.
Okay, let's end this.
those data that comes straight from Google Earth, straight from Google, shows a mountain range in Antarctica higher than Mount Everest. We weren't.
What?
What?
Repeat that.
I thought everything in Antarctica was below the Himalayas, because of course it's south.
So there are two possibilities I see here. Either he's flat out lying, or he's misunderstanding something.
Could be
maybe mixing up the difference between height over base of the mountain and height over sea level. Or he's just found an artifact somewhere in the map that just happens to be higher, right? And by artifact, I mean a fuck up in the height
Matrix.
data.
Glitch in the matrix. Oh.
Exactly.
More garbage.
All the garbage.
Told about that, but it's in the data. So for all of you who want to keep coming up with your straw man arguments, I love the one too about angular momentum, when I showed about the sun doesn't necessarily have to pick up speed, and all I heard was, I don't understand angular momentum. But then when I showed Chris UK's video where the stars in the sky must show different distances or different speeds depending where you're on the Earth, then angular momentum doesn't matter there. In fact, that's what's in the comments.
Stop.
Yeah, what the hell was that?
Okay, so I see two problems. If he's going for the AE model, which usually describes that the sun is like circling above the AE model with the North Pole in the middle, then you will run into a problem with angular momentum, namely as soon as the sun is going to move up or down, depending on the season, right?
Exactly, yeah.
So therefore, winter should take winter on the Northern Hemisphere should take longer than on the Southern Hemisphere.
Yeah, and it also happens during any.
Bullshit. Wait, stop. No, the length of day should change. Right? Yeah, because if the sun were closer to the equator, closer to the North Pole, it would rotate faster. Therefore, a day would not take 24 hours, but less.
Yes. So during the winter solstice, the sun would need to move a lot faster around the circle it makes than during the summer solstice on the flat Earth map. And but we don't see the sun traveling faster across the sky. Nowhere.
No, we don't. We have
it always
50 degrees per hour.
Yeah, it always goes. Yeah, it always 15 degrees per hour. Yes, exactly.
Yeah, I mean the idea of a close sun is just so amazingly stupid, and the fact that they think that the sun is what I forgot, 4,000 miles up. In other words, it's closer. For instance, if in the UK, it's closer to you than say the US is. So, yeah, and the moon as well. So in other words, people at different sides of the Earth would be able to see the opposite sides of the moon. You'd be able to see the opposite sides of the Earth, the sun. I mean, the consequences of this are just so ridiculous, and they are obviously the sun. Given the fact that it's closer to the UK than the US is, the change in size, I think, given the orbit that it's supposed to have around the say it's over the equator, so it's in midsummer, whatever. It's the change in size for someone on the equator is I think it changes by a factor of 5 or something.
Yeah, it's somewhere between 3 and 5. I don't know exactly.
And of course, it's got to be visible all the time. I mean, it just kind of, it's just where do you start? It's so screwy. It's very difficult to know where to begin. What's the other thing you're pointing at? Yes, and also the speed. And obviously in the winter and the summer, which I think is the point that Nestle was making, if it's got those different different orbits in the summer and winter, then obviously it's got to speed up and slow down as well. If it's going to maintain its angular velocity with a different radius of different radius about the North Pole, then it's got to something has got to supply it with a force to make it speed up, and then cycle through this, get slow down, speed up, slow down, speed up. Well, where's the forces to create this change in velocity, change of position as well? I mean, Cool Hard Logic did some fantastic videos about this for a geocentric Earth, where the sun is having to move either up and down in space relative to us to get the seasons. Where's this force going from? What's causing it to go back? Whereas, of course, we've just got one force with the heliocentric sort of solar system, and that's just going around the sun, and that's it. There's a force known to gravity, and it doesn't change. You just simply it's constant. So there's no variation in force. There's just one constant force, which we know is gravity, and that's all you need to do to get all the orbits.
That's not completely correct. The force actually changes.
Oh, well, okay. There's elliptical.
The force is dependent on the
it's slightly elliptical. Yeah, okay. I was simplifying that slightly because there's an eccentricity in the Earth's orbit of what's the eccentricity of the Earth's orbit? Is it 0.05 or something? Or is that
it's like 5 million kilometers or so.
Yeah, the eccentricity is a special term to describe the elliptical shape. Yeah, the actual variation in the eccentricity has got a special mathematical term, but yeah, the actual change in radius is it's about
like 0.1 something.
Yeah, so yes, you're absolutely right, Gio, that there is a difference in force, obviously, because it's elliptical. Therefore, the further we get away in the apogee is going to be smaller than the perigee. So yeah, there will be a difference, but it's not caused by a change in the strength of the field that's causing it. It's just we're moving in an elliptical orbit, and therefore we go through different the force calculation changes. Whereas the sun is having to go through, and on the flat Earth is actually having to move different positions and back again. And so whatever force that's doing that would have to change it and would have to change over time. Whereas the Earth going around the sun does not require a change of force over time.
More garbage.
Yeah, let's finish the garbage. Well, probably we won't, but let's try at least.
Yeah.
So you get the argument both ways. Can you see people just want to hang on to the cognitive dissonance? These things can be shown over and over and over again, and people come up with these arguments and things like that. And I think I'm starting to figure out why these people keep coming back. I get comments like, haven't you seen the videos of people proving the globe? Why do I need to go watch that? I've seen NASA and science.
Stop. Has anybody of us today brought up NASA in a way, or any other space agency?
Not that I know of.
I don't recall a fact time small.
You can already see how biased he is against things to prove him wrong. So he doesn't do anything. He doesn't look up any rebuttals to his claims.
Yep.
Yeah, you get the when he blocks comments, and he obviously sort of got a bunker mentality where he doesn't cope with criticism because he deep down I think he knows that he can't cope with it. you're being validated. The same with Nathan and others, where they censor criticism is the only option they've got, because and of course they don't understand maths. If you ask them to give numbers to anything, they immediately fall apart. And of course, you can't do science without doing maths and numbers.
Yeah, more garbage.
Hundreds of millions dollars a year fail at doing that for the entire history of my life on the earth. Anyway, they failed. Why do I need to see other people also fail at doing it? But these people, why do they come? What if they're so convinced the earth is round? Why do they keep coming to flat earth videos and comments?
Easy, because it's hilarious.
Yeah. It is the easiest type of internet sport today.
Well, and there's of course the fact that some people are stupid enough to believe this, and at some point or another, that's going to have negative consequences, not only on them but on society in general.
Yeah,
and that's something that it needs, well, at least needs to be addressed, right? Not necessarily because the people that are spewing this need to be, well, converted is maybe the wrong word, but
yeah.
I guess you know what I mean. But the people watching this, right? That the people watching their videos at least get to know that the counterpoints are made, right?
Yeah. But basically, what he is saying right now is, why won't you let us spout nonsense all the time without criticizing us? Well, because we care about what is true, and the flat Earth is not true.
Yeah, and they want to do things like change science. I mean, there was some pillocks were saying you shouldn't have a position on the sphericity of the Earth. You should say, just like evolution, it's up for debate. You've got to just put one point and then say this is a point of view, and then there are other points of view. No. We've got the measurements. We've got the pictures. we can.
It's not only the shape of the planet or evolution. What worries me, for example, is something like climate change, right? Where it's always shown that there's some sort of neutrality bias, so that either it is true or it's not. The odds are 50-50. No, it's not. It's not 50-50. We've proven this shit. Yeah. And every counter-quote argument that is made is shown to be utter bullshit.
I think it's 98 or 99% of climate scientists believe there's a man-made global warming. I think it's
closer to 19. I think the latest figure that I've seen was 99.6.
Really? Oh, bloody hell, right.
Oh, yeah, it's only like background noise at this point.
Right, God, I didn't realize. Oh, wow.
Yeah, and the remaining percentages are all hired by Exxon or something.
Yeah, right. Yeah,
well, perhaps not, but it was just a joke.
All right, I see.
Yeah.
So, you're probably right there, actually. Damn, I forgot my. Yeah, because the point is, they're fighting ignorance here, and it's ignorance that's going to get, as Gio says, going to go into trouble with climate change or anything else. And we're fighting this sort of refusal to accept the history we've got of learning, and the sort of conspiracy theorists, the flat earthers, the anti-evolutionists, the anti-climate change people are all anti-authority, anti-vaxxers. Yes, there's a really good one, isn't it? And so that whole sort of approach to the world is what we're really fighting here, and flat Earth is part of that.
Yeah, and anti-GMO.
Yes. Yeah. It's all part of so it's that sort of set of people that we're tackling by eliminating. We're tackling. It's not just as well as being a lot of fun and very easy. It also makes you feel quite clever, of course, when you well, I don't know, something. It's quite fun. It's so easy to debunk these people. It's actually quite intellectually amusing to think, and it's doing the right thing.
Yeah.
Oh. Let's continue.
Yes.
Many. Is it because you're not sure? Because something tells you deep in your mind something's wrong. See, I don't...
Stop. Yeah, there's something wrong. There's definitely something wrong. There's something wrong with society in general, I think.
Yeah.
That those fringe views still exist, right? It points to either a complete, well, how can I say this?
Failure of education.
Either failure of education, or it's a failure of human thought in general. That there's something wrong with our biology that makes us susceptible for this, right? That there's a major flaw in our brains that can lead to this.
Well, we are all plagued by biases and are subconscious. But I think there is, of course, an external factors that contribute to these trends.
Well, I think it's a lot of people I think a lot of people resort to the conspiracy theories, flat Earth, anti-vaxxers, all that sort of stuff. Is that they're not doing very well in society, so they want to reject society in all its aspects. So anything society says is wrong because I don't like it, because I'm not doing very well.
There are several researchers that have investigated the psychology behind the appeal of conspiracy theories, and I think I remember there was one because they want everything to be ordered. They cannot accept it, so that something happens randomly, so they have to spin a narrative that connects these random events in a giant narrative that makes everything seem connected in some way.
Yes, that's another good point, actually. Yes,
Yeah.
that's an additional point to the ones I was making. Yes, I think that's a good one. There is particularly if you feel, it's the same need. I mean, they identified a gene for wanting to believe in God and things. That you like to believe there's something looking after you. There's a big power out there that's ultimately going to sort of favour you as a person, as a human, that you can talk to in some ways. And if you believe in a personal sort of God, then obviously you feel it can do things.
Well, I'm very skeptical about the gene for the believing God.
Right?
So,
yeah. Okay. I mean, it's just
if there is a genetic component, but I'm not sure if it is, but it would not be it would not be simple as a gene, of course. But anyway, let's move on with the videos before we go on.
Let's bring this to an end.
I don't go to Globe Earth videos. No, I don't go and watch them. Why should I? I know the Earth is flat. I know.
Stop.
No, you don't know.
Let's finish the
Knowledge
video
is
before.
demonstrable.
Let's finish the video before.
The Earth doesn't move. $50 to $60 million a day goes to NASA, and they haven't proved it to me. What are amateurs going to do?
I have to stop here. It's not NASA's job to prove that the Earth is a sphere, because it has already been done. NASA's job is, well, it's two things, actually. It's to, well, first of all,
it has several jobs, like scientific inquiry and also
scientific inquiry of everything that has got to do with the space, right? We are curious about what shit happens in our solar system, for example.
But also what's going on.
We just recently discovered 12 new moons of Jupiter.
Really?
Yes, we did. Now counting 79.
I knew it had 70, but that's gone.
Yeah, but NASA also monitors things like the Earth's climate, which is why Ted Cruz got really upset about how NASA is proving that climate change is happening.
Again, of course, there's the military use, right? At least at one part. For example, GPS.
Oh yeah, yes. So it has several purposes. Did I hear somebody's stomach growl?
I was just saying.
Yeah, this is usual Swedish dialect.
Hey, I'll fucking.
I agree, Gil.
Okay, but so there's. I don't think people are aware of how many use cases there are for technology. Like, I think a fun one is the MRI machine. That's based on space tech.
Yeah.
It's because a company that was and X-ray machines for airports. That's also actually space tech. It's only there because, I'm not going to say it's only there because, but it's there mainly because there was a company that had built an X-ray small enough that you could actually put it in those kind of devices, because it was meant for a satellite.
So, do you know what the MRI machine was actually used for?
I don't remember what it was initially for.
Because what the MRI machine is in itself is just an NMR spectrometer in a different, packaging in a different shape and a different size. So usually when I deal with NMRs, we use them to check the chemical environment of hydrogen atoms. So we can see what atoms the hydrogen atoms inside a molecule actually interact with.
That's amazing. I still think that's amazing, Gio.
I know, it's cool.
Also, Gio, there are only 16 seconds left, so don't pause it.
Okay, let's do those 16 seconds and then continue talking for maybe 10 more minutes or so.
It's almost done.
That's all I have for this video. Stay in your cognitive dissonance if you want.
What? Stainger, what now?
No, why did you pause it? Why did you pause it? It's almost done.
Want to repeat it?
Amateur's going to do. That's all I have for this video. Stay in your cognitive dissonance if you want. If you want to do the work and grow up and be an adult, you can prove this yourself. It's right in front of your face. Take care, guys. Bye.
Did you just say cognitive distance or something?
Something like that.
Yeah, I mean, he misspoke. That's not too bad. That shit happens. I misspeak all the time. Fuck it.
Yeah. I can't judge either.
No.
What a dickhead. Only that sort of confidence can come with complete ignorance and Dunning-Kruger on a massive scale. It's just...
Just want to check. Is there maybe like a 2-minute video that we can debunk of him? Like a really short one. 6 minutes.
Or perhaps you can bring a flat earther here from the live chat. Oh god.
Actually, no. I have to leave very soon. I mean, tomorrow is a work day for me, so.
And I think Red's
is going to start 10 minutes. Huh?
I think Red's Rhetoric is going to start the hangout soon too.
No, I think later. I think it's announced for 22:30 my time. That's 20:30 UTC, so that's in 2 hours approximately.
In 2 hours, yeah. That's what I said soon. Soon as in 2 hours from now. So, relatively speaking.
Yeah, I mean that one picture. Just getting to that one picture with the 2 poles in it. He was no, he didn't know. That's true. We showed it. He didn't show any. No, he did. Did he? He did show a picture with 2 sort of poles of the rotation, didn't he? Oh, I can't remember now. I was just thinking, but that in itself, that one picture just tells you that the axis of rotation of the Earth or the universe around us, whichever you can't prove it, whichever it is aligned north to south.
Actually, Rumpus, you can prove it, but it's a little bit annoying to do, at least.
And so right, okay, but
not with this. You cannot do it this way. You need a different technique.
Yeah, well, obviously you can prove that the Earth is not the universe is not rotating simply by the fact that if you get out as far as Uranus, the stuff would have to be rotating at the speed of light.
That's one thing. The other thing is, for example, you can measure the red and blue shift.
Yes.
That's caused by actually the movement of the planet in its orbit.
Yes, to the sun. Yeah, you can see. Yeah, exactly. And to the microwave background radiation, you can see.
Which is hilarious. And in the hangout with the Reds and Journalism actually claimed that you can't measure the speed of the planet. You can just scale everything up, which is complete bullshit for this exact reason. The red and blue shift would not be identical at the different, rotational speeds around the sun, right? If you have 1 year of period, and you would have twice the distance, obviously you would need twice the orbital speed. Therefore, you would get a different red and a blue shift.
Right. Yeah. I mean, the movement of the Earth leads to red and blue shifts, which you're not going to get. Going around in an orbit, you're going to get different one of those, and it actually causes the information they gather for the microwave background radiation to be shifted as well.
Yes, that's true.
And you would not get these sorts of effects if it was wiggling around us. Unless the whole universe, I suppose, periodically was jiggling around.
and Tom, no, it's not pseudoscience because we can observe the blue and red shift.
Yeah, we can put
that's observable.
Yeah, we can put numbers to things. People who can't put numbers to things can't do science. If you can't put numbers in them, you can't do science. And you'll notice that all the flat earthers cannot cope with an equation. They cannot cope with putting numbers to anything. Yeah. If you ask them about buoyancy or something, you say, here, tell me what the buoyancy of this thing is. They wouldn't be able to do that. Yeah. They can't even cope with telling you what the size of a triangle length would be. I mean, they are sort of intellectually the sort of level of a 13-year-old in school. If
below that, they obviously that math is worthless because it disproves their beliefs.
Yeah, it's they're easy to identify. Any flat earther, and any other flat earther probably won't notice in any other flat earther because they'll never ask them a question about maths. But immediately, if you're a glober and you come across someone who can't do maths, you didn't know they're not equipped to understand many of the issues that you'll describe to them, and you have to basically fill in their whole 3 or 4 years worth of education just to get them up to speed where they understand what they don't understand. At the moment, they don't understand what they don't understand, so therefore they can believe their wishful thinking drives them because they're not contradicted by anything they understand in science because they don't understand science. Everything's flexible for them. They're not constrained by reality or physics or maths, so they can believe anything.
Mm-hmm.
Whereas people here actually have to make sure their beliefs comport with lots and lots of things to get them right.
Okay, and I think I'm gonna end this hangout for today, for the simple fact that I'm getting tired and need to get up tomorrow very early. So or does anybody have to add anything? Bo, maybe, or Hellsoy?
No, I'm done for the stupid today. Maybe. No, wait. There's still Red's rhetoric
coming up.
going on later. So
And who's he talking to again?
What does this title say?
Isn't it? Or was that someone else? Someone
Let's
else?
see. The title is Flat Earth and the EQ Telescope.
Oh, okay. That's the one. So there was a guy in the live chat yesterday that claimed he could demonstrate that the equatorial mount can work on a flat Earth.
Ooh, that will be interesting. Is he going to show up, or probably an hour later? But still, is he going to show up?
Part-time vegan, is it?
No. Someone else. Somebody else.
Ian something.
Yeah.
Oh.
Okay.
I can give you the a Dropbox link for the video that they looked what his video they destroyed that thing.
Okay, guys. Again, I'm gonna end this. Thank you very much for joining or watching. See you next time. I don't actually know when I will have the next hangout. I just want you to know that there are actually 3 currently that are being planned. I just don't have the dates yet. So there might be something funny, yet disturbing, yet brain-breaking, yet hilarious, yet making it necessary to drink until you're almost dead in the near future. So maybe in the next 4 to 6 weeks, something like that.
Well, remember, flat Earth stupidity is limitless.
Yes, it is. Indeed.
Oh, yeah. Sadly, it is.
Flat Earth stupidity is limitless and doom is eternal. So see you next time.